Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If each and everything has been perfect, just write perfect over the live chat and then we are going to start. And keep in mind, as far as the sequence of our subjects are being concerned, at very beginning we would be starting with engineering mathematics, and then we would be moving into the aptitude, and then we would be moving into the common subjects like control system, then we will be going into the analog, then we will be going into the control system, and end of the day the common subjects is being dealt, then we will be going into the specific subject like power system, power electronics, measurement and all. Is that part clear? So probably at very beginning we are going to take few number of questions from the mathematics. As far as the number of questions we were having from the mathematics, it must be known to all of us. Let me show you exactly how many number of questions were there from the each and individual branch. So let me see that, just a minute. So total 65. Let me focus over the distribution part. So in total 65 number of questions. Just a minute. Yes, in total 65 number of questions, the 5 number of questions were there from network theory. So the student who are going to appear in instrumentation and electronics, they can have a note of this particular segmentation so that they would be better prepared for the tomorrow's examination. So 5 number of questions were there from the network theory, and the 7 number of questions were there from electrical machines. 7 number of questions were there from electrical machine. Similarly, from the control system, total 4 number of questions were there. Control system. So the electronics and instrumentation people, they can expect approximately 4 to 5 number of questions from this particular segment. From the power system, the number of questions were huge. The total 7 number of questions were there from the power system. Power system. Power system. And similarly, in power electronics, total 8 number of questions were there. Power electronics. Power electronics. And from the electrical and electronics measurement, only 1 question was seen. Measurement. Measurement. And from the analog, we had total 5 number of questions. That's been huge, because analog and digital together makes a single subject, but from the analog itself, the 5 number of questions were seen. And similarly, the 2 questions were there from the digital. Anyways, in community post, I am going to list down this all bifurcation. And then from the electromagnetic field theory, we had the 3 number of questions from the EMFT. And similarly, from the signal system, we had the 5, and engineering mathematics, we had 8. Signal system, we had 5, and similarly from the engineering mathematics, we had 8. And in standard, from the aptitude side, we had the 10 number of questions. Among them, the 5 were 1 marks, and similarly remaining 5 was 2 marks. And specifically the students who are there from instrumentation and electronics, they can expect, they may not have any sort of MSQ in the tomorrow's examination, because the number of questions as far as the distribution of the question pattern are being concerned, MCQ, MSQ and NAT. Let me see that distribution. So there were no questions from the MSQ. Yeah, there were no questions from the MSQ. And similarly from the MCQ side, there were the 43 number of questions, and the remaining questions were from NAT side. Yes. So this has been the distribution of the complete different questions. So till this point, I don't find any of the student would have any kind of doubt. So anyways, I think it's been the right time. Straight away we will be focusing over the few number of questions which had been experienced from the mathematics side, and then we would be moving forward for the aptitude. So may I know what was the answer for the question number 1? This has been a simple square matrix, and then we need to satisfy the 6a inverse is equals to of a square plus of c times of a plus of alpha I. Then we need to find the c and alpha exclusively, and end of the day we had to add them together. The 4 different options were there. Definitely the type of questions were the MCQ. So may I know what was the answer, whether it was 5, whether it was 17, whether it was 11, or whether it was -6? tell me. I would like to have the input from each one of you, and if any mistake is been there in question, you can write over the comment box as well, so that we would be trying to correct that question as well. So may I know what was the best most answer for this given question? So here comes the question. See, this was the problem from the Kelly-Hamilton. So the student who had gone through the concept of Kelly-Hamilton easily must have been cracked this problem. See, as far as this square matrix is being concerned, first we will be calculating its characteristic equation. And how the characteristic equation is being defined? For any square matrix, the characteristic equation has been defined as the determinant of a minus of lambda I, where the lambda is being eigenroot or eigenvalue, and then has to get compared with 0. So the process has to be followed as it has been given. This has been a square matrix. The 1 is going to get subtracted with lambda. 0 remains 0, 0 remains 0. 0 remains 0, the 4 gets subtracted with the lambda. And here we will be having minus of 2, then it goes 0, then it goes 1, then it goes 1. Minus of lambda. Again the determinant has to be calculated, has to get compared with 0. I get 5, that's correct. The 5 has been the best most answer. Then the determinant has to be calculated, and then it is going to be a cubic equation. As the lambdas are being experienced in 3 diagonal rows, definitely we are going to have a cubic equation over here. I'm not going to solve the complete cubic equation. Probably the input I have already had, I'm just going to use it. So the outcome which we had been getting is been lambda to the power of 3 minus of lambda to the power of 2, and here it goes 6 of the lambda minus of 6 is equals to 0. And as per the Kelly-Hamilton theorem, all of the characteristic equation is getting satisfied by its own matrix itself. That means the lambda can be easily replaced with a. So as we start replacing lambda as a, it becomes a cube, it becomes a square, it becomes 6 of a. And keep in mind, here it was a pure integer, but now it is going to be a matrix. So the identity matrix I is going to get multiplied and has to get compared with 0. Has to get compared with 0. Now what we are going to do, just we are going to rearrange this complete equation in this format, and we will have 1-to-1 comparison, and from there we will be getting the value of c as well as alpha. Is that part clear? So the same thing has been done, and that calculation is already made. And yes, what I am going to do, 6a is being kept as it is, and the remaining part is being shifted towards the left hand side. So here the factor which we are going to get, it's been 6 of a inverse. 6 of a inverse is equals to of a square minus of a plus of 6 of i. 6 of i. Is that part clear? Now I think it's been the right time to just have a comparison between these two equations, the equation which had been supplied along with this problem and the equation which we had concluded during our calculation. And once we'll be comparing, 6a inverse is being very same as the 6a inverse, a square is being very same as a square. Now the c is being in place of minus of 1. So one conclusion at least we can deduce out of it, it's been c is been minus of 1. Is that part clear? And similarly, alpha is being 6. End of the day, as far as the problem is being concerned, we had to focus over their addition. The value of c has been minus of 1, and now it's going to get added with the 6. The result which we are going to get, it's been 5. Agreed? So the student who had got the answer as 5, that had been extremely well. And the student who are from electronics and instrumentation, they can experience this sort of question in tomorrow's class. Is that part clear? So this must be clear to all of us. So I think it's been the right time focusing over the next question as well. So the student who have got the answer as 5, that had been the perfect most answer. That had been the perfect most answer. I think it's been the right time focusing over the next question as well. So here comes the next question. This has been a problem from analog that we will be taking after some time. This has been the problem from network we will be taking after some time. Network, again analog I am going to take. Even few questions from control I would be taking. So straight away let me hop into the next question from the mathematics side again. A very well designed problem, very well crafted problem. So here comes the question number 16. You need not to focus over the sequence and all, just focus over the question. And one more important thing, do not focus over the options as well, because even the options are being well shuffled. One student might have seen A as S1 is correct, and the another student might have seen S1 is incorrect in the same question. So you need not to focus over the options. No, that part I am going to make it clear. So here comes a question. Here comes a question. May I know what would be the best most answer for this given question? The problem states e to the power of a is defined as the exponent of matrix A, and its eigenvalues are being lambda and v are being the eigenvector of the matrix A. Consider the following statement. The two statements are being supplied. S1 is being e to the power of lambda is the eigenvalue of e to the power of a. Then S2, V is the eigenvector of e to the power of a. The four different options are being given. S1 is correct and S2 is incorrect. S1 is incorrect and S2 is incorrect. Both S1 and S2 are being incorrect and both S1 and S2 are being correct. So may I know what had been your answer? What had been your answer? What had been your answer? Tell me, what was your answer? See, as far as this problem is being concerned, no, this problem is being based on the concept of eigenvalue and eigenvector. Anyways, this has not been the right time to focus over the detailed study of eigenvalue and eigenvector, because this has been a very precious time, and I know many of the students who are from electronics and instrumentation, they wants to know only crux of each and individual question. That is why we are not going to spend much time over the either of the question. We will be just specific to the question and the method through which the question can be smashed. So here comes the eigenvalue and here comes the eigenvector. Anyways, the eigenvalue and eigenvector, lot to learn, lot to teach, but focus over the question itself. May I know what could be the best most answer? So answer has started coming as per the Tripti. Satpati, the answer is being C. Anyone else apart from Tripti? My dear, the best most answer is being C. My dear, how did I know about it? See what happens if you had a square matrix A, and let's take their eigenvalues are being lambda 1, lambda 2. Let's take it's been a n cross in order, so obviously the n lambdas would be involved. They could be repeated, they could be pure real, they could be imaginary, the different kinds of these structures we can have. But one thing has been quite sure, the n number of lambdas we are going to have, that is for sure, no issue. Now what had been happening, I had started making a polynomial taking the help of this A. That polynomial could be a to the power of 2 plus of a plus of 3, or that polynomial could be order of n. N could be 2, 3, 4, 5, 6, 7, anything. May I know what had been the e to the power of a? When you are going to extend the e to the power of a, no, it is going to be 1. 1 in matrix form, it's going to be identity matrix. Then we are going to have matrix A divided by of 1 factorial. Then we are going to have a matrix A square divided by of 2 factorial, so on and so forth. Obviously e to the power of A had been an infinite series expansion, so it will go till the infinite term. Yes sir, no issue. Now what had been happening, my dear friends, now the A is being replaced with a lambda, and as the A is being replaced with a lambda, what is going to happen, each and individual A is going to get replaced with a lambda. And as the each and individual A is going to get replaced with a lambda, what would happen? It had become 1 plus e to the power of lambda plus of e to the power of 2 lambda divided by 2 factorial, e to the power of 3 lambda divided by 3 factorial, so on and so forth. And end of the day, the one of the best thing which had been happening, from one side we had the e to the power of a, another side we had the e to the power of lambda. What does that mean of it? That means as far as this problem is being concerned, e to the power of lambda eigenvalues of e to the power of a is being a perfect most statement. S1 has been verified. And the student who had a little bit idea about the eigenvector, my dear friends, if you keep expanding a certain square matrix in a form of polynomial, eigenvalues are supposed to change. But taking the reference of new eigenvalue, the eigenvector remains the same, which we have got it for the same matrix. So what had been happening? As far as matrix A is being concerned, let's take its eigenvalue is been lambda, and now we had taken a new matrix e to the power of a, its new eigenvalue would be e to the power of lambda. But if for the first case the eigenvector is being x, no, eigenvector is not going to change. So the conclusion is being, if you arrange any of the matrix in a form of a polynomial, eigenvalue changes its value in the terms of new polynomial, whereas the eigenvector remains very same. Anyways, a little bit derivation part is being involved. Within 3 to 4 lines we can have the derivation itself, but I think it's not the right time to discuss about the derivation and all. So obviously the student who had given the answer as C, that is going to be the perfect most answer. Yes, so Tripti, this has been a very perfect answer. So in the same sequence, I think it's been the right time focusing on the next question as well. So I do not exactly remember how many questions I have brought it over this PDF. Let me check it out. Yeah, the next question was the question from the probability density function. A simplest question which we can ever expect. A very simple question we had. Just a minute. May I know what was the best most answer for this given question? Probably almost all students who had gone through a little bit concept of PDF must have smashed this problem well. Tell me, what was the answer? So the problem states, let the probability density function of a random variable is being given by f of x is equals to of a e to the power of minus 2 mod of x. It's also been called as absolute of x. Then the value of a is been. The value of a is been. Tell me what could be the best most answer for this given question. Tell me what was your response. And then we will be moving ahead with few more number of questions. And one situation may also take place. Probably I could have not segregated all of the mathematics question in one shot. So probably after me, the ma'am is going to take your aptitude. Then again, I may come back with the mathematics. That may come, that may come, that may come. So let me focus over this question and then we will be moving forward. See, in this problem, it had been clearly shown that the f of x has been a genuine PDF. If f of x has been a genuine PDF, the area under the curve has to be 1. If you want to understand the problem graphically, f of x is equals to of a e to the power of minus 2 divided 2 into mod of x is being a pure even function. The curve is going to be sort of this. Yeah, obviously, sir. This has been the positive axis of x and this has been the negative axis of x, and here goes the probability density function f of x of x. F of x of s. If f of x of s is being a genuine PDF, its area under the curve has to be 1. That indicates the integration from minus infinity to infinity of f of x dx has to be precisely 1. So what we are going to do, we are going to take the integration from minus infinity to plus infinity. The f of x has been defined as a e to the power of minus 2 mod of x over d of x. What I feel, this problem must have been designed in the better way. They could have given the range of x as well, because sometimes what happens, the PDF is being defined only and only for the positive value of x, negative value of x, or for the bandwidth of the x. Anyways, whatever the data are being given, we had to solve the problem according to that data. Nothing is being given, we will be presuming that the x has been prevalent from minus infinity to plus infinity for all span of the x. Yes, agreed, sir. So in the same sequence, we will be moving forward and we will be taking its integration. And as it had been an even function, what we are going to do over here, we are going to apply a property which we had seen in a part of definite integral. Rather taking the integration from minus infinity to infinity, we would just be taking the integration from 0 to infinity. And as we know, the area which will be made towards the left hand side is being very same as the right side. So just 2 is going to get multiplied. Agreed, no? And now what had been happening here, it becomes a e to the power of minus 2 mod of x. Here it is going to be defined as a to the power of e minus 2 mod of x. For the positive value of x is been defined as a plus of x, and towards the left hand side it had been defined as a 2x. So just focus over this part, and yes, we will be comparing with 1. The integration is very simple, and from here the value of a which we are going to get, it's been simply 1. So the student who had got the answer as 1, that had been the perfect most answer. That had been the perfect most answer. Is that part clear? So let me take the next question as well. So here comes the next question. Let me see whether I have got that question or not. Yes, this problem was a problem from the vector calculus side. The problem states we had a vector field which had been written as a e vector that had been defined as a 2x. This component has been falling in the direction of ax cap. Similarly, we had the 5y. This component was falling in the direction of ay cap, and then we had 3z that had been falling in the direction of k cap. That had been the falling in the direction of k cap. And in this problem, they were seeking the volume integration. Such a easiest problem, probably this could have been the problem, not more than 1 marks for any cost. So this has been focusing over the divergence of this vector quantity, and they had been focusing over its volumetric integration, where the limit of x, y and z had been clearly supplied with the problem. Yeah, so x has been varying from 0 to 1, the y was moving from 0 to 1, and even the z was moving from 0 to 1. And yes, it was a type of MCQ, and probably that options are not at all required. Within 1 minute you will be able to smash this problem well. May I know what could be the best most answer? Ma'am, after this question you are going to take, yeah? Tell me what could be the best most answer. See, the simplest form of the method which we are going to apply is going to be, the divergence is going to be applied over this vector quantity. Obviously this vector quantity is been written in the Cartesian coordinate. Straight away the 2x is going to be partially differentiated with respect to the x. So as far as the divergence of E is being concerned, this has been 2, then here goes 5, then here goes 3. Put together the divergence part is been 10. Divergence part is been 10. In the same sequence we will be moving forward, just we are going to place the datas which are being supplied. So the x is been moving from 0 to 1, the y goes from 0 to 1, and z goes from 0 to 1. And the data which were there with the problem has been replaced with 10, and here comes dx, dy and dz. And once we'll do the integration, it's gonna be x, y, z. Limit is gonna be 1 minus 0, 1 minus 0, 1 minus 0. So probably this has been the 11th class question. It's simply gonna be 10. Still few more number of questions are being left from the mathematics side, but let me consolidate those questions, and definitely I'll come back with those questions as well. So the student who are from the electronics and instrumentation, they should not leave the complete portion, because you are going to have a little bit idea which kind of the questions you can experience in the tomorrow's examination. And one of the most important thing, the MSQ has not been seen in electrical side. The number of questions from the MCQ side were 43, and the remaining questions were from the NET. So this has been the structure of the question. Okay, ma'am, please.
Thank you so much, sir. Now let's discuss some of the questions from the aptitude section. I really hope all of your exams went pretty well. So let's start with the very first question. Here I am having the memory based question. So here we have first question in this. In a 500 meter race, in a 5-meter 100 race, P and Q have speeds in the ratio 3:4. We have speeds in the ratio 3:4. Okay, and Q starts the race when P has already covered 140 meters. So let's take an example. Let's suppose this is the 500 meter race, and when Q is going to start the race, P already covered 140 meters. P already covered 140 meters. So the remaining distance is nothing but 360 kilometers. Sorry, 360 meters, right? Now, what is the distance between P and Q in meters when P wins the race? So here it is given that P wins the race. How we are going to solve this? So the speed is in this ratio, and they both are moving in the same direction. They both are moving in the same direction. So let's take an example. The remaining distance at the time in which P covered the remaining distance, Q started the race from the very initial point, and he has to cover whole 500 meters. So let's first calculate in how much time P covered 360 meters with 3 meter per second speed. So time required by P to finish the race, that is nothing but equals to 360 meters divided by, let's take it as 3 or 4. We multiplied both with the 1 because the speed is given in our ratio, so we can multiply the both factors with a common number, right? So here we get the speed, here we get the time, that is nothing but equals to 120 seconds, right? So in 120 seconds, P wins the race and reach at this point. While in the same time, Q covers how much distance in this particular time? With the speed of 4 into 120, that means 480 meters. So we can say that when When P reaches at this point, Q is somewhere at this point at the distance of 480 meters, right? So what we have to calculate? We have to calculate the difference between the P and Q. So the difference is nothing but 500 minus 480, that means 220 meters. The correct answer is nothing but, the correct answer is 20 meters. This is a very easy question. Now let's move to the next question. The next question is from the concept of LCM. So the question is, three bills P, Q, R are rung periodically in a school. Here we have the three bills. Here we have three bills P, Q and R. They rung periodically in a school. P rung in every 20 minutes. In every 20 minutes. Q is rung in every 30 minutes. And R rung in every 50 minutes. So here we have the additional details is, if all the three bells are rung at 12 p.m. At 12 p.m. if all these rang together at 12 p.m. then when will be the three bells rung together again at the next time? And here we have some options, that is 6:30 p.m. Option B 5:30 p.m. Option C 5 p.m. and option D 6 p.m. So how we are going to calculate this? First we have to take the LCM of all these numbers. What is the LCM of 20, 30 and 50? Can you tell me in the comment section what is the LCM of 20, 30 and 50? It is 300. This is the LCM. We are calculating these terms in minutes, that means this is 300 minutes. So we can say that after 300 minutes they rang together. That means we need to convert these 300 minutes into the hours. So how we can convert this 300 meters into the hours? That means we have to divide it by 60 and we'll get 5 hours. That means after 5 hours of this, they rang together. That means the correct answer is 5 p.m. The correct answer is 5 p.m. That means option number C is correct. That means option number C is correct. This is a very easy question. Now let's move to the next question. This is the puzzle. It is given that the letters P, Q, R, S, T and U are placed in one per vertex on a regular convex hexagon. So here we have a question based on hexagon. Okay, this is our hexagon, but not necessarily in the same order. Consider the following statements. The line segment joining R and S is longer than the line segment joining P and Q. So it is given that the line joining R and S is longer than line joining P and Q. This is a condition which we have in the question. The next condition is the line segment joining R and S is perpendicular to the line segment joining P and Q. That means RS should be perpendicular to PQ, right? This is the very second condition. And the third condition is the line segment joining RU. The line segment joining RU is parallel to the line segment joining TQ. This is a parallel to TQ. Okay, so here we have the three conditions. Now based on the above statement, which of the following option is correct? Okay, so first we try to draw the diagram. Let's suppose here we have R, right? Let's suppose here we have R, or we can say Okay, RS is greater than PQ, right? So, if RS is greater than PQ, then it's better to take it as diagonal. So, this is the diagonal, right? So, we can take R and S here, right? And it is given that it is longer than PQ. It is longer than PQ. So, what we can do, we can simply draw PQ as but we have to take care of this condition as well. RS is perpendicular. That means it should be perpendicular. That means PQ should be here, right? So if we measure these distances either with the help of some theorem, we get this condition satisfied, right? And here this condition is also satisfied. Now we have to draw TQ, or we have to plot TQ and U. So we satisfy all the conditions. So here we have 2 points and TQ. Okay, TQ, RU, TQ. Okay, if we talk about this is the parallel to, this is parallel to RU. This is parallel to RQ. So here we have options. The first option is TQ is perpendicular, the line segment TQ is perpendicular to PU. TQ is perpendicular to PU. Option number B is QS is perpendicular to RP. All these options are available in the language. Option C is RT is parallel to QS, and the last option is RP is perpendicular to UQ. So with the help of this diagram, we can say that QS is perpendicular to RP. QS is no. We can say that RT. So TQ is perpendicular. TQ is perpendicular to PU. No, this option is not valid. PQS is perpendicular to RP. Where is RP? No, this option is also eliminated. RT is parallel to QS. RT is parallel to QS. Yes, RT is parallel to QS. So the correct option is option number C. All these options are available in the languages. We do not have the correct verdicts. So we take the example, we take the options like this only. So the correct answer of this is the line segment RT is parallel to the line segment QS. Okay, I really hope this question. Okay. So here we have one more question from the syllogisms. It is very easy. Let's take that question also. Here we have some statements. Statement 1. Statement 1 is some bottles are cups. Some bottles are cups. And the statement 2 is all cups are knives. All cups are knives. Now we have conclusions as well. Here we have 4 conclusions. The first conclusion is some bottles are knives. Some knives are cups. All cups are bottles. And the fourth one is all knives are cups. So if we draw the Venn diagram from this statement, it is something like some bottles are cup. some bottles are cup, and from this second statement, all cups are knives. All cups are knives. Now check each conclusion. First conclusion is some bottles are knives. Some bottles are knives. Yes, this is definitely true. Some knives are cup. Yes. Some part of knife and cups are common. That means this conclusion is again definitely true. All cups are bottle. All cups are bottle. We can only say about this part. We can't say anything for this part. So this is can't say. All knives are cups. All knives. Again, we can't define about this part. So this is also in can't say condition or in can't say part. So here only first and second conclusion follows. Only statement 1 and 2 follows. Right? Okay, now let's move to the next question, which we have from the profit loss. The price of an item is 10% cheaper in an online store S as compared to the price in another online store M. Okay, here we have two stores. First one is S, store S, and the second one is store M. And it is mentioned that the price of item is 10% cheaper in store S. Let's suppose it is 90 and this one is 100. There's a difference of 10% in between these two stores, and it is also mentioned that store S charges 150 rupees for delivery. 150 rupees for delivery. There is no delivery charges for orders from the store M. That means there is zero delivery charges, right? A person brought the item from store S and saved rupees 100. A man purchased item from store S and saved rupees 100. What is the price of item at online store S in rupees if there is no other charges than what described above? So we can say that, let's take it as 90x, because here we have a value, or we can say the percentage, and here the value. So we have to convert this thing in value. We have to convert this thing in the value. So we can write it like 90x plus 150 delivery charges. If this is subtracted from the 100x, that means the person saves 100 rupees. This is the equation which we get from the given data in the question. So we have to solve this. 10x is equals to, okay, 10x is equals to 100 plus 150. That means x equals to 250 upon 10, that means 25. The value of x is 25. Now what we have to calculate it? We have to calculate what is the price of the item at online store S if there is no other charges. So if there are no other charges, that means we have to calculate the value of 90x. What we have to do? We have to calculate the value of 90x. Just simply put the value of 25 here and we will get our answer. 90 into 25 and we will get it as 2250. 2250, and for this we have options like 1750, option B, 2500, option C, 1500, option D, 2250. That means the option number D is correct. That means the option number D is correct. This is a very simple question. Okay. Here we have a very simple question from the verbal ability, and it is and that is as you grow older, an injury to you, filling the blanks, to your may take longer, filling the blanks, and here we have option heal and heal. Option number B, that is heal and heal. Option number C, heal, heal, and option number D, heal and heal. Anyone in the comment section, what is the correct answer of this question? This is a very, very, very easy question. Anyone in the comment section, what is the correct answer of this question? Okay, so here it is mentioned that you may take longer. It means we are talking about some time, and longer to heal. To heal, that means to fill up. That means the option number, the second filler should be heal. That means this option number B is eliminated. Option number C is also eliminated. Now here, as you grow older, an injury to your, that means here we are talking about some body part, that means this should be heal. So the correct answer is option number A. So the correct answer is option number A. This is a very, very, very easy question. And now Santan sir will continue and we will discuss some other questions of aptitude quite later. Okay, let's take one more question. Here we have a question in which we have 4x4 block diagram, and the question is an ant is at bottom left corner. That means ant is present somewhere here. Let's take it as P. Of a grid point P as shown above, it aims to move the top right corner. That means it aims to reach at this point, right? The ant moves only along the line marked in the grid such that the current distance to the top right corner strictly decreases. That it means that the ant should only move from this marked point. Which one of the following part of the possible trajectory of the ant during the movement? And here we have some options. Option number A is this. Option number B is option number C is, and option number D is. Okay. As we see with the help of options, these two options, option number D and option number B is directly eliminated because there is no point to move in this direction, right? And there is no point to move in the downwards direction, right? So option number D and option number B are directly eliminated. And what this ant have to do, this she or he wants to reach at this point, right? She wants to reach at this point. Then why she move like this? The only possible answer is option number C. The only possible answer is option number C. So here we can take it as it moves like, or she moves like, this. She moves something like this, right? So here we have some more questions from aptitude, but we will discuss it later because we do not have the correct data. So first we have to gather that correct data and then we will discuss it. So now Santan sir will try to convey what questions come from his part. Okay, thank you.
Okay, ma'am. Thank you. लिंक तो आप कहाँ से निकालोगे कैसे? Hi students, welcome to GATE Academy Global. How are you? And how was the paper today? How was the paper today? क्वेश्चन ऐसे देख लेंगे, कोई बात नहीं, इसे देख लेंगे. How was the paper today? Paper was awesome. Actually, core subject was very easy. The questions from the core subject was just from the fundamental only. Okay, just from the basics. So we will be starting with the first question, and that was from economic load dispatch. Economic load dispatch. Okay. What is the question? Economic load dispatch. First question is cost was given. Cost was given 350 plus 6P1 plus 0.004 P1 square. Okay, and obviously unit of this cost was rupees per hour. Okay, the unit of cost is rupees per hour and the unit of incremental cost is rupees per megawatt hour. Okay, and IC2 is, in fact C2 is cost of the second plant is 450 plus AP1. A is unknown here. A is unknown here. Okay, AP2 plus 0.003 P2 square. This is also rupees per hour. P1, P2 are power generated by plant 1 and plant 2 respectively. Okay, in megawatt, A is the constant. This power incremental cost was given as 8 rupees per megawatt hour. Okay, in 8 rupees per megawatt hour. So the total demand is 550 megawatt. So what should be value of P1 and P2? What should be the value of P1 and P2? Okay, this is the easiest question possible in power system analysis. This is the easiest question possible. Okay, as this is cost and we have to first calculate incremental cost. Okay, so DC1 by dP1 will be equal to 6 plus 0.008 P1. Okay, similarly DC2 by dP2 should be equal to DC2 by dP2 should be equal to A plus 0.006 P2. Okay, and for the optimum cost, incremental cost of all the units in operation must be same. Okay, incremental cost of all the unit in operation must be same. So 6 plus 0.008 P1 is equal to A plus 0.006 P2 should be equal to 8. Hence, from this equation only you can calculate P1, and P1 should be equal to 8 minus 6 divided by 0.008. This should be equal to 0.008 and this should be equal to 250 megawatt. Okay, so P1 is 250 megawatt and the total load was 550 megawatt. So P2 should be equal to 550 minus 250, and this will come out to be 300 megawatt. This is the easiest question possible. Okay, so this was the answer. 250 megawatt, P1 should be 250 megawatt and P2 should be equal to 300 megawatt. Okay, let's see next question. I think most of the students must have done this question. Okay, let's see second question. What is second question? Second question is from stability, angular acceleration. Angular acceleration. Question is 20 MVA, 11.2 kilovolt, 4 pole. Here the number of pole of the machine is 4 and 50 Hertz alternator. 50 Hertz alternator has inertia constant H is given as 15 megajoule per MVA. 15 megajoule per MVA. H is given as 15 megajoule per MVA. If the alternator mechanical input and electrical, if the input and output of the system, P mechanical is 15 megawatt and P electrical is, which is output, that is 10 megawatt, okay, respectively. The angular acceleration in mechanical degree per second square, mechanical degree per second square, okay. So you must have remembered this formula, swing equation, m d2 del by dt square is equal to pm minus pe. Pm minus p, this is just a starting formula of stability, okay. So d2 del by dt square should be equal to d2 del by dt square should, this is angular acceleration, okay. Pm minus pe divided by m, Pm minus p divided by m, and the unit of this expression, that is, this is angular acceleration, okay, and this unit is electrical degree per second square. This is electrical degree, but in question answer should be in mechanical degree. Answer should be in mechanical degree, okay. So Pm is equal to mechanical power is equal to 15 megawatt, electrical power is equal to 10, okay. P is Pm minus P. Mechanical input is 15 megawatt, electrical output is 10 megawatt. Pm minus P divided by m is equal to Gh by pi f. M is equal to Gh by pi f. Gh by pi f, okay, Gh by pi f, and this is should be equal to 5 divided by G into H, kinetic energy stored, 300 into pi f into pi into f. Pi is equal to 180 degree into 50 hertz is f is equal to 50 hertz, and this should be in electrical degree per second square, but we have to convert it into mechanical degree, okay. We have to convert it into mechanical degree. So you must know one thing, theta is equal to p by 2 into theta m, okay. So to convert electrical degree into mechanical degree, we have to multiply it with p by 2, okay, p by 2. So theta m should be equal to 2 by p into theta e. Theta m should be equal to 2 by p into theta e. So this is 5 into 180 degree into 50 divided by 300 into electrical degree into 2 by p is equal to mechanical degree, okay. So 2 by 4 mechanical degree per second square, mechanical degree per second square. So calculate it, 1 by 2, 6, okay, 30 and 15, 75 mechanical degree per second square. The answer is 75 mechanical degree per second square. This is the simplest question possible from stability, power system stability, okay. The answer is 75 mechanical degree per second square. I think most of the students must have done this question. Now next question. The valid positive, negatives and zero sequence. The question is the valid positive, negative and zero sequence impedance in per unit respectively for a 220 kilovolt fully transposed 3-phase transmission line is. Always you should remember one thing, positive sequence impedance is equal to negative sequence impedance in case of transmission line. In case of transmission line, positive sequence impedance should be equal to negative sequence impedance, and the zero sequence impedance is having the maximum magnitude, okay. So zero sequence impedance must have of the maximum magnitude. Positive and negative sequence impedance must be same. Positive and negative sequence impedance must be same. So the option should be A option. in A option, x1 is equal to 0.15, x2 is equal to 0.15, and x0 is equal to 0.35. 0.35. Okay, in case of transmission line, I have told you so many times, in case of transmission line, positive sequence impedance is equal to negative sequence impedance, and the zero sequence impedance is of highest magnitude in case of transmission line. But in case of any machine having rotating part, positive sequence and negative sequence impedance is almost same, but lesser than but positive in case of machine having rotating part, in case of machine having rotating part, always remember one thing, x1 is equal to x2, x1 is almost equal to x2, and this is greater than x0. Okay, now the next question is the most commonly used relay for alternator in case of excitation, in case of loss of excitation. Most commonly used relay for protection of an alternator against the loss of excitation. The option A option was Buckles relay. B option was Buckles relay. B option was differential relay. C option was overcurrent relay, and the D option was offset more relay. Everybody knows that the Buckles relay is used for transformer protection. Buckles relays are used for transformer protection. Differential relays are used for the protection of any winding, like alternator winding, transformer winding. Okay, in case of transformer, this differential relay becomes merge price protection. Okay, so these are used for winding protection. Overcurrent relay cannot be used in case of loss of excitation. As in case of loss of excitation, current cannot be more than a certain value. Okay, current cannot be more than a certain value. In fact, current will be almost zero. So the offset more relay is generally used for loss of excitation. Okay, now the next question is, the question were very simple. Question were just from the fundamentals of the power system, basics of the power system. Okay, the next question is, if only, this question was very confusing. Question is, if only 5% of supplied power to a cable, 5% of supplied power to a cable, if only 5% of the supplied power to a cable reaches the output terminal, the power loss in cable in decibel, in decibel. Okay, so this question is very simple. Okay, let us suppose that we are supplying input power as 100 megawatt. Let's suppose P in is equal to 100 megawatt. Okay, so the P out is equal to 5 megawatt. P output is equal to 5 megawatt. So what will be the loss? So P loss is equal to 100 minus 5 megawatt. 95 megawatt should be the P loss. 95 megawatt should be P loss. Okay, 95 megawatt is P loss. Now if we want to convert it into decibel, okay, so the power loss in decibel should be equal to minus 20 log P loss divided by P input. P loss divided by P input. This is power loss in decibel. This is power loss in decibel. Okay, so this will be equal to minus 20 log P loss is equal to 95 megawatt divided by 100. 95 megawatt divided by 100, and we have to convert it into percentage. I think we have to convert it into percent. We have to convert it into percent. No, in decibel just. Okay, so calculate it. Calculate it. This should be equal to log 0.95 is equal to log 0.95 log 0.95 into 20. This is 0.4455 megawatt. Okay, this is 0.4455 megawatt. This is 0.4455 megawatt. This is losses in decibel. Okay, this is the losses in decibel. Okay, so this question was just formula based. This question was very easy. Every question from the power system was easy. Every question from the power system was very easy. Okay, so I think you must have done most of the questions. You must have done most of the questions. So for Atif Ali, Nitesh, 0.445. Yes, Nitesh, very good. 0.445. We have to multiply it minus 20. That's why it will come out to be 0.445. Okay. So the next session will be. Renu sir will be taking next session. Okay. You can ask me anything if you have any doubt from the gate paper, electrical. Relatively question was easy. I think relatively question was easy. Cutoff will be above 40. No, cutoff never goes like above 40, above 50. Cutoff will be somewhere around 30 only. You can ask me any question if you want related to gate paper. हाँ कर तो सकते हैं. क्वेश्चन एक मिसिंग है. Okay, sorry. This was the question. This is balanced source. Balanced source means voltage of all the three phase must be same. RMS voltage of all the three phases must be same, and phase displaced by 120 degree. Okay, and the phase should be displaced by 120 degree. This is balanced load, balanced source. This is balanced source, but the load is unbalanced. And you must know, in case of unbalanced load, potential of neutral cannot be zero. But here the question given is, this impedance is 10 ohm, this impedance is 20 angle 60 ohm. By varying value of this ZC, you have to make this potential zero. So how can you make this potential zero? Just apply KCL here. Assuming that the voltage is 0 volt only. And you must know what KCL says. KCL says that summation of total outgoing current at any node must be 0. This is, I think, simplest form of KCL. Okay, summation of total outgoing current at any point must be 0, at any node must be 0. So current in this line should be equal to potential difference divided by impedance. Okay, so the potential difference is here 0 volt, and the here voltage is 100 angle 100 root 3 degree. 100 root 3. Okay, 100 root 3. Okay, this is 100 root 3. So the potential difference is 0 minus 100 root 3. Okay, 0 minus 100 root 3. Same here. This is in the, what will be current in this line? This should be equal to 0 minus 100 root 3 angle minus 120 degree divided by ZB is 20 angle 60 degree. And current in this line should be equal to potential difference 100 minus 0 minus 100 root 3 angle 120 degree divided by, this is ZC. You have to solve this equation. You have to simply solve this equation. I think this question was gift. Okay, so you can solve this equation very easily. Okay, 10 root 3 angle 0 minus we have taken common, 5 root 3 angle minus 180 degree plus 100 root 3 by ZC angle 120 degree should be equal to 0 degree. This is 10 root 3 angle 0 degree. This is 5 root 3 angle minus 180 degree. 10 root 3 is in 0 degree direction. 5 root 3 is in 180 degree direction. So the resultant of this will be 5 root 3 angle 0 degree. 10 root 3 is in 0 degree direction. This is in 0 degree direction. You don't have to use calculator always. Okay, 10 root 3 is in 0 degree direction and 180 degree is in this direction. So the resultant will be equal to 5 root 3 in this direction. So the 5 root 3 angle 0 degree, plus 100 root 3 angle 120 degree divided by ZC is equal to 0. So what should be the value of ZC? ZC is equal to minus 100 root 3 angle 120 degree divided by minus 100 root 3 angle 120 degree divided by 5 root 3 angle 0 degree. 5 root 3 angle 0 degree. Okay, 5 root 3 angle 0 degree. So this is equal to minus 20 angle 120 degree. So you can write it 20 angle minus 1 is angle 180 degree. Okay, so this will come out to be angle 300 degree, and angle 300 degree can be easily written as 20 angle minus 60 degree ohm. So the ZC should be equal to 20 angle minus 60 degree ohm. Okay, this was the question from power system analysis. Power system analysis, as I always say, is the simplest core subject. Power system analysis is easiest core subject. You have to work hard. You have to work very hard if you don't want to solve any question from power system. Okay, power system question is so much easy. Okay, so now Renu sir will come and hello sir, hello. Okay, thank you so much, and I wish you all the best. Be happy and always try to improve yourself. Thank you so much. We will be meeting on Gate Academy main channel soon. Thank you.
Okay, yeah, good evening everyone. So first I will take question from digital electronics. Only 2 question has been asked, and that is very easier question. Okay, already I have discussed in my last session in digital also that kind of question. Okay, so first question was given here. First question from the digital. So first I am going to take question from the digital. So from digital first question is given. So from digital, okay, first question. Okay, so first question they have asked, a mod 2 and a mod 5 up counter are connected in a cascade. So here one mod 2 counter, this is a mod 2 counter, and this is a mod 2 up counter. Okay, this is mod 2 up counter, and one more, this is a mod 5 up counter. This is a mod 5 up counter. Okay, so this two mod 2 and mod 5 counter are connected in a cascade. So now they are asked, okay, so what is a complete mod? So what is a complete mod counter? So this is very basic and very easy question. So we can say, sir, this is a mod n counter. So what will be the answer of this mod? So we know very well. Okay, so mod 2 counter will divide frequency by 2, and mod 5 counter will divide frequency by 5. So what will be the total frequency division here? So what you can say here, what will be the total frequency division if suppose this is a f clock? So here your frequency will be f clock by 2, and here f clock by 2 divided by 5. So can I say, sir, this is here f clock by 10. So you can say this is nothing but a frequency divider by 10 circuit. So we can say this is nothing but mod 10 counter. This is a mod 10 counter. So directly we can multiply. So if 2 counter are connected in cascade, so directly easily we can multiply. So here n is nothing but a 2 into 5. 2 into 5, and this is nothing but 10. This was very easier question. I hope all of you definitely have handled this question within 30 seconds. Okay, so I hope everybody have definitely solved this question. Okay, so anybody tell me how much time you have invested for this question? How much time you have invested for this question? 30 seconds, sir, 1 minute, sir, 2 minutes I have invested. How much time? Okay, so this was very basic and very easy question. Now one more question. Only 2 question has been asked, and the previous question was 1 mark question. Now the second question. From digital, question number 2. Question number 2 from the digital. Here they have provided the maximum clock frequency in megahertz. So they are asking maximum clock frequency in megahertz, a 4-stage ripple counter. So they have provided 4-stage ripple counter. So if suppose I am considering here 4-stage ripple counter. So suppose this is first stage. Again I can say this is second stage. Again this is third stage. And we have one more 4 stage. This is 4-stage ripple counter. Ripple counter means this is asynchronous counter. So in this question, suppose this is LSB flip-flop. I can say, sir, this is your clock. So it can be up counter or it can be down counter. So I can say this is T0, this is Q0, this is Q0 bar, this is T1, this is Q1, Q1 bar, and this is T2, and Q2, and this is Q2 bar. And last one is your T3, and this is MSB flip-flop, Q3 and this is Q3 bar, and this is Q3 bar. And now this first output is connected to the next clock, this output is connected to the next clock, this output is connected to the next clock, and this is your final output. This is your final output. So if examiner are interested in what is the maximum clock frequency for asynchronous counter, so for asynchronous counter, what is your app clock max? So how much maximum clock frequency we can provide? So this is nothing but directly you can write, sir, 1 upon this is total delay. This is total delay. So what is the total delay of this block? What is the total delay of this block? And every flip-flop delay they have provided, that is 20 nanosecond. So here every flip-flop delay is given, sir, this is 20 nanosecond, and this delay is 20 nanosecond, and this delay is 20 nanosecond, and the last one is 20 nanosecond. So this kind of question, how easily we can handle? So directly you can assume, sir, here we have, this is a complete digital circuit. Sir, we have here, this is a clock, this is asynchronous circuit. Sir, here directly we can find out the final output. This is a final, what is the total delay of the circuit if asynchronous category of circuit is given? So here easily we can say total delay is 18 nanosecond. So here this total delay is at 80 nanosecond. So what is the maximum clock frequency we can provide? So this is nothing but 1 upon total delay, and total delay we can say, so this is 1 upon 80 nanosecond. So here examiner asks, this is NET category of question, and here they are asking in megahertz. Okay, so they are asking in megahertz. So in megahertz how we can handle? In megahertz how we can write? So sir, this is app clock. Sir, this is app clock maximum is equal to, you can write, sir, 1000 by 80. 1000 by 80, and nano you can write, this is now micro you can write here. So this is nothing but megahertz. So 1000 by 80, you will get this answer 12.5. So here the answer should be 12.5. This answer is 12.5. So in numerical answer type in bracket, you have to mention here 12.5. Okay, 12.5, and they have asked rounded up to 1 decimal place. In this question they have asked rounded up to 1 decimal place. And in our previous question, they have asked in integer. So here in integer you have to put 10, and here you have to mention 12.5. So only this 2 question has been asked. Okay, yeah, this is not a very tough question. This is very easier question. Both question you can say, both question easily you can handle within 30 seconds. Okay, so only 2 question has been asked from the digital electronics. Okay, now so next subject. Okay, so next subject I am going to take. Okay, so this is from the digital. Okay, this is from the digital. So anybody can say, have you attempted both the question from digital? Okay, please just comment me. Then I am going to start the next subject, and now I am going to start next subject, network theory. So next question I am going to take from the network theory. Okay, next question I am going to take from the network theory. Okay, so shall we start now? So now first question from the network theory, very basic and very easier question they have asked. Very easier and very basic question they have asked. So first question, question number 1 I am going to take here. Question number 1 from your network theory. So now I am going to take question from the network theory. Okay, so first question is here. A very basic circuit is given. So in this question, just I am going to draw the network here. Okay, one 6 ohm resistor and one 3 ohm resistor are connected in parallel. Okay, and this value is 6 ohm and this value was 3 ohm. And now here one capacitor was given. This is one capacitor and one series resistor, and here one supply is given. This is minus and plus. This is 10 volt supply. This capacitor value is 1 microfarad. This resistor value was given. This is 10 ohm and 10 ohm. Now one more series resistance was connected here, and now all this connected with this line. So this question was given, and here in this question they have asked, in the circuit shown below, the switch S is closed at t is equal to 0. So here one switch, here one switch was connected actually here, one switch was connected actually, one switch was connected, this is switch, and this switch is going to close at t is equal to 0, and now this resistance is given 2 ohm, this resistance was given 2 ohm. So here the switch is going to close at t is equal to 0, okay, and now they are asking the magnitude of steady state voltage in a volt across the 6 ohm resistor, across the 6 ohm resistor. So here across the 6 ohm resistor, examiner asked magnitude of the voltage, they asked magnitude of voltage, direction you can assume anything, direction you can assume anything here, okay. So they are, examiner asking here only the magnitude of this voltage, only magnitude of the voltage, but at steady state, so at steady state this voltage you have to find out. So this was capacitor, so we know very well at steady state capacitor behavior is open circuit, so we know this thing at steady state, capacitor is equal to open circuited, capacitor is open circuited. So from here we can say, at steady state switch was closed, this capacitor was open circuit. So what was your network? This is your 6 ohm, here this is 3 ohm, here this is 6 ohm, here this is 3 ohm, and this capacitor was open circuited, so this resistor does not affect to the circuit, this is open circuited, and this resistor is your 10 ohm, and here this is 6 ohm, and here this is 3 ohm, and now your supply is 10 volt, this supply is 10 volt, this is plus, this is minus, here one more resistor we have, this is your 2 ohm, this is your 2 ohm. Now you can see, sir, what is the parallel combination of this? Sir, what is the parallel combination of this? Here voltage we have to find out, but first if I will find out what is the parallel combination of this, sir, 6 parallel 3, so what you will get, 6 into 3 by 6 plus 3, 18 by 9, this standard value, this is nothing but 2 ohm. So this parallel combination is 2 ohm, sir, this is open circuited, so here this is 10 volt, and this 2 and this 2 are in series, this 2 and 2 are in series, so you can say, sir, this is a 2 ohm, this is a 2 ohm, here this is a 10 volt, here this is a 10 volt, and here we have one more 2 ohm resistor, this is your 2 ohm, so 10 by 2 plus 2 you can say. So current you are getting 2.5 ampere, so current you are getting 2.5 ampere. In another word you can say, sir, these two are connected in series, so can I write what is a voltage here? So here voltage you will get, this is a 5 volt, and here you will get this plus minus 5 volt, here you will get plus minus 5 volt, and now this 2 ohm is nothing but this complete combination, so can I say, sir, here this is plus minus 5 volt, sir, here voltage is plus minus 5 volt. What is the answer here? So what is the answer in this question? So this answer is, sir, 5 volt. And now, sir, it will be minus 5 volt or plus 5 volt, so you have to concentrate. Examiner have asked in this question what is the magnitude of this voltage. So what is the magnitude of voltage? So you have to put only the positive value here. So here the answer is 5 volt. So in bracket, so this is a numerical answer type question, and you have to put answer 5. Okay, answer 5. If you have put on here minus 5 volt, so maybe you will get here, okay, 0 marks in this question. So here answer will be 5 volt, because examiner have asked clearly, they have mentioned what is the magnitude of the voltage, what is the magnitude of the voltage, okay, what is the magnitude of the voltage. Okay, so this was very easier question. Okay, in mind easily we can handle, sir, this 6 parallel 3, sir, this is 2, this is open circuited, 2 plus 2 are in series, so here this is 5 volt and 5 volt, so here answer is 5 volt. So within 15 seconds in mind easily we can handle this question, easily we can handle this question, easily we can handle this question. So this was easier question. Okay, this was easier question. Now I am going to take another problem. Now I am going to take another problem, okay, from the network theory. Now I am going to take another problem from the network theory. From the network theory.
हो गया क्या सर?
नहीं, ये चैट नहीं दिख रहा है वहाँ किसी का. ओके, नाउ ये नीचे नहीं जाएगा क्या? ये नीचे. Okay, so please comment everyone. Okay, please comment everyone. Okay, now Now the next question I am going to take. I hope everybody have put answer for the last question, that was 5 volt. Okay, so now the next question I am going to take from the network theory. Okay, again this is very easier question. Again this is very easier question. So this is the next question. So this is another question from the network theory. In this circuit, okay, one network is given. This voltage is given 75 volt, and this is plus minus. And here one resistor was given, and this resistor is 2 kilo ohm. And current flowing through across this resistor is mentioned here I. And now here one dependent source was given. And this dependent source value was, this is plus minus, this is 0.5 V1. This is 0.5 V1. And then here this is connected with this bottom line. And now one more dependent source is connected here. One more dependent source in this way, and one more last resistor. This was the question. And here this resistor is given 8 kilo ohm, and this voltage is given, sir, this is plus minus, this is voltage V1, and here this is dependent value, and this is current source, and this current source value is I. So this was the your network. And in this question, in the circuit shown below, the magnitude of the voltage V1, again they are asking magnitude of the voltage this one. So they are interested in magnitude, they are not interested in the here, they are not interested in the direction. So only magnitude means positive value we have to put. So V1 value across the 8 ohm resistor we have to find out, rounded up to nearest integer. So here answer should be in integer. So here answer should be in integer. Okay, now if anybody want to know, sir, this question was for 1 mark or for 2 marks. So this is a 2 mark question. So this was a 2 mark question. So this was a 2 mark question. So this was a 2 mark question. This was a 2 mark question. Anybody can tell me answer for this? Anybody can tell me answer for this? Anybody can tell me answer for this? Okay, and this previous question was 1 mark question. This was 1 mark question. This was 1 mark question. This was 1 mark question. Okay, now, so easily we can handle. How we can handle this question? So easily within 1 minute, anybody can solve this question. How? You can see here, sir, if a current is flowing from here I, and same current is moving here, so how much current will he flow from this? This is a 0 ampere. This is 0 ampere. Suppose if you are going to assume, sir, this as a ground, but here the current is 0 ampere, you can say this is a 0 volt, but this will be not required. Now you can say, if I will write here one KVL, so what you will get? You will get from here, this is 7.5 is equal to, you don't write here kilo. If you will not write kilo, then your current will be in. Your current will be in milliampere. Voltage is in volt, resistor is in kilo ohm. This resistor and this resistor, both resistor are given in kilo ohm. So only here current value you have to find out, but answer you will get in milliampere. So here you don't write here 2 kilo ohm, just you can write this is 2. So here the current is 2I, and this 2I plus, sir, this is 1 by 2 V1. So here 2 unknown V1 and I, but here you have to calculate this V1. So one more equation you will get from here. So this current is again I. So from here can I write, sir, V1 is equal to 8 into I, and now this I value you can put from here. This I value we can put from here. So what is the I value? So this 2I, so from here this 2I is equal to, so 7.5 minus 1 upon 2 V1, okay, divide by 2. So this I is nothing but this 7.5, sorry, this is not 7.5, this is 75. Okay, this is not 7.5, okay, this is 75. Okay, this is your 75, not 7.5. This is not 7.5. This is your 75. This is your 75. So here this is your 75. So sir, this is your 75. So this I is nothing but 75 by 2 minus of 1 by 4 V1. Minus of 1 by 4 V1. So now you can put the value here. So here you are getting, in another way, this V1 value you can put here, and I value you can find out, then I value you can put here. You have 2 choices. So now this is 8I. So you can multiply by 8 here. So 8 into, this is 75 by 2. 8 into 75 by 2 minus of, sir, 8 by 4 into V1. This is a value of V1. So here you are getting, sir, V1 is equal to this 8 by 2. You will get here 8 by 2 means 4 into 75. 4 into 75 is nothing but 300. Minus of this is 2 of V1. So here you are getting V1 plus V1. This is 3V1. 3V1 is equal to 300. Sir, V1 is equal to 100. This V1 and this unit will be always in volt. So voltage unit is in volt, current unit is in milliampere, and resistor unit is in kilo ohm. So you don't have to write here kilo and milli. So examiner have asked what is the voltage across this 8 kilo ohm, and they are interested in only magnitude. So just you have to mention, this is again numerical answer type 2 mark. So here you have to mention the answer is, you have to mention your answer is 100. So here answer is in the bracket, okay, in the numerical answer type you have to put here 100. You have to put here 100. So answer is 100 volt. Answer is 100 volt. Answer is 100 volt. Okay, so now one more question I am going to take from the network. Okay, and this is a very good problem, very good problem. So another question, and this is again very good problem. This is very good problem. Okay, now so this, if this question definitely you can also handle in power electronics. Okay, and you can also handle in your network theory. Okay, so just I am going to write in this question, Vt is provided, voltage is provided, one voltage is provided, and this voltage is, sir, 230 root 2, 230 root 2 sine omega t. This is sine omega t, and the unit is a volt. Unit is a volt. Okay, since voltage is provided, and here omega is mentioned, sir, omega is 2 pi into 50. Omega is mentioned 2 pi into 50 radian per second. Radian per second. Okay, and then one current is also provided. So this is a voltage and current across a rectifier. Okay, and here current is also provided. This current is 10 sine, okay, omega t minus of pi by 3. Omega t minus of pi by 3 plus this is given 4 sine 3 omega t minus of pi by 6. Okay, now this is number third. Here 3 harmonics they have given 3 sine, this is 5 omega t minus of pi by 3. Minus of pi by 3. This thing is given. This thing is given, and the examiner ask what is the input power factor rounded up to 2 decimal place. What is the input power factor? What is a input power factor? So again this is a numerical answer type question. So all the 3 questions in network, they have right now asked all the questions numerical answer type, and here this is rounded up. This is rounded up to 2 decimal places. So till 2 decimal places you have to write the answer. You have to write the answer. You have to write the answer. Now come to the question. So you can see here one, you can say circuit is given. This circuit can be anything. This is a electric circuit, you can say, and here voltage is provided and current is provided. So you can say here voltage is provided and current is provided. And now examiner asking what is the input power factor. This is a good question, and this is a 1 mark question. Okay, this is a 1 mark question. This question is a 1 mark question. This is a 1 mark question. Okay, already I have also discussed in our network theory. Last classes I have discussed this question. Okay, same category of question, only some values is different. So you can see here voltage is given, current is given. So in this category of question, how we can handle? So we know very well, sir, what is the P average of this kind of circuit? So P average is nothing but V1 of RMS, V1 of RMS into I1 of RMS into cos phi 1. Can I write? So only this one is for the fundamental frequency. Fundamental frequency is omega here, and here fundamental frequency is omega here. This is not a fundamental frequency, this is not a fundamental frequency. So this is from here you can find out I1 RMS, from here you can find out V1 RMS, and this is your cos phi 1. And from here you can find out phi 1. So what is your P average value? So what is your P average value? Sir, V1 RMS, this is nothing but 230 root 2 by root 2. So you can write, sir, this is 230 into what is I1 RMS? This is nothing but 10 by root 2 into what is cos phi 1? This is 180 by 360 degree. So this is your cos 60 degree. This is your cos 60 degree. So from here we can get P average. So from here we can get P average. So P average if you have calculated. So now sir, what is the total power of this circuit? So sir, total power of this circuit, another formula directly we can write. Sir, this is whole circuit Vrms, whole circuit Irms into cos phi, whole circuit power factor, this is power factor. So from here, sir, whole circuit power factor cos phi is nothing but this power factor of the circuit, or you can say input power factor is nothing but, you can write, sir, this is P average by, this is Vrms into whole circuit Irms. So from here you can put this P average value. This P average value is nothing but, sir, this is 230 into, sir, this is 10 by root 2 into, sir, cos 60 into cos 60 divided by this cos 60 degree divided by Vrms. V1 RMS and Vrms was same. So this is again 230. This 230 and 230 will be cancelled out here. Sir, this 230 and 230 will be cancelled out here. Multiply Irms. So now the important thing, what will be the whole circuit Irms? Sir, what will be the whole circuit Irms? So already this I was given. So from here you can write, sir, what is Irms of the circuit? What is Irms for this circuit? So you can write, sir, this is nothing but root over first RMS value. So you can write 10 by root 2 square, 10 by root 2 square plus second value is your 4 by root 2 square, 4 by root 2 square plus third value is your 3 by root 2 square, 3 by root 2 square. From here what we will get, 10 square 100, 100 by 2, 100 by 2. So what you will get, this is root over 100 by 2 is, this is nothing but 50. From here 16 by 2 you will get 8, and from here you will get 3 square by 2 means 9 by 2, 4.5, 4.5. So here you will get 58, 58 plus 462 root over 62.5. So from here we can put the value, root over 62.5. So directly first we have to calculate P average. We have to calculate this P average, otherwise this value you can put, and now you can divide with this value. And now this answer we are getting, this is approximate 0.447 something, 0.448. But examiner have asked till okay, decimal 2 point. So till 2 point decimal, some student can write 0.44 and some student can write 0.45. So according to me, both the answer will be correct here. Both the answer will be correct here. So according to me, both the answer definitely will be correct here. Okay, both the answer will be definitely correct here. Okay, so this 3 question just I have discussed from the network theory. Okay, from the network theory. Okay, now there are some more question from the resonance. Okay, and that I will discuss later. Okay, so I don't have okay, so 2 questions asked from the resonance in from the network theory. Okay, that I will discuss later. Okay, so now the next session will start now.
किनको ट्रांसफर कर रहे थे क्या अभी किसी को? कार्तिक सर अगर रेडी हैं तो ले सकते हैं, कोई इशू नहीं है. Hello everyone. So probably me or Karthik sir is going to engage the next upcoming session. That solely depends on the availability of Karthik sir. So just wait for next 1 to 2 minutes. Definitely we are going to start the next session. Karthik sir there? Yes. So now this session is going to get handover to Karthik sir, and then I will be coming back with few number of questions from analog and control system. Okay, then hand over to Karthik sir, please sir.
Okay. Hi everyone. So we are going to discuss questions in EMTR. So they have given 2 questions in EMT. So this is the first question. So see here, they have given the H field. H field is equal to x square ax cap plus x square y square ay cap plus x square y square z square az cap. So this is the H field they have given. So the units of this field is ampere per meter. Okay. So then they are asking us to determine the magnitude of current density in ampere per meter square. Okay. The units of current density is, anyway, it is ampere per meter square. Right. So they have given H bar and you have to determine the magnitude of Z bar. So which one we can use here? We know that from Ampere's law here, from Ampere's law, we know that curl of H bar is equal to what? Is equal to Z bar. So they are asking the magnitude of Z bar, that means you have to determine the magnitude of curl of H bar, right? Okay. So how to write this curl of H bar here? So I can write this curl of H bar as a dou by, so here I am writing here Ax cap into dou by dou y minus dou by dou z, right? So here I can write H z component and here I can write H y component plus ay cap, the y component I am writing ay cap into dou by dou z minus dou by dou x. So here I am writing the x component, here you have to write the z component, okay, plus az cap into dou by dou y, sorry, dou by dou x minus dou by dou y, right? So here you have to write the y component and here you have to write the x component. So this is nothing but curl of H bar here. So this is nothing but curl of H bar. Okay. So in the given expression, so what is the x component of magnetic field here? That is x square. So this is nothing but hx. So the y component I am considering as a hy, right? And this is z component I am considering as hz. So just substitute this hx, hy and hz in this expression here, in this expression. Then you are going to get what? Then you are going to get this curl of h value, right? Okay. So what is a curl of h? What is hz here? Hz is nothing but x square y square z square. So if you differentiate, hz is nothing but x square y square z square, and here hy, what is hy? Hy is nothing but x square y square. Hy is nothing but x square y square. And here hx, what is hx here? Hx is nothing but x square, and here hz is nothing but what? X square y square z square, right? And here hy, what is hy? X square y square, and what is hx? Hx is nothing but x square, right? Okay. So if you do this, what you are going to get, tell me? So this is equivalent to, this is equivalent to. So if you differentiate this function with respect to y, you are going to get 2y x square z square, right? And here if you consider hy is a function of what? Only x and y. It is independent of z. So if you differentiate with respect to z, you are going to get 0 here. So minus 0 into what? Into ax cap plus ay cap plus ay cap into plus ay cap into. So what you are going to get? So differentiate this x component of H field with respect to z. So here the x component is a function of only x. So if you differentiate it with respect to z, you are going to get 0 here, minus here the z component is x square y square z square. So if you differentiate it with respect to x, what you are going to get? 2x y square z square, right? Okay, plus az cap. So this is z component, az cap, right? So differentiate the y component with respect to x. What you are going to get? You are going to get 2xy. And here hx is a function of only x. If you differentiate it with respect to y, you are going to get 0. So this is curl of h bar here. This is curl of h bar, right? Okay. Okay. So they are asking determine magnitude of z bar. So here I forgot to write something. So at x equal to what? At x equal to 1 comma y equal to 1 and z equal to 1. So this is what they have given here, right? So they have given x, y and z values, right? Okay. So now see here what you are going to get. So substitute at x equal to 1, y equal to 1, z is equal to 1. So what you are going to get? What you are going to get? Magnitude of, sorry, curl of h. Curl of h bar is equivalent to what? Is equivalent to, so substitute x equal to 1, y equal to 1 and z equal to 1. You are going to get 2ax cap minus 2ay cap plus what? Plus 2az cap, right? Okay. So from this Ampere's law, we know that magnitude of curl of h bar is equivalent to what? Magnitude of z bar. Okay. Okay, yeah. So therefore magnitude of z bar, we want magnitude of z bar which is equivalent to magnitude of curl of h bar. So at what here? At x equal to 1, y equal to 1 and z equal to 1. So what is the value of curl of h bar magnitude at x equal to 1, y equal to 1 and z equal to 1 is nothing but what? Is nothing but square root of 2 square plus 2 square plus 2 square. Yes or no? Okay. Okay, yeah. So that is 4 plus 4 plus 4, that is root 12, square root of 12. So you can write this as a 2 root 3, right? So what is the value of 2 root 3 here? So the value of 2 root 3 is nothing but 3.464. Okay. So 3.464 you are going to get. So the units are nothing but what? Ampere per meter square, right? So we have determined the magnitude of z bar. The units of z bar is nothing but what? Ampere per meter square. So this is the answer for this question here, right? Okay. Okay. So next question here, next question. So this is the second question they have given in EMT, right? So what they have given here is they have given the current density z bar is equivalent to z suffix a r cube az cap. Okay, the units are nothing but ampere per meter square. So this is the current density they have given. So here the current density is a function of what? Function of r. So this is what they have given. So is the current density carried by a long cylindrical wire here, long cylindrical wire of radius b. Its radius is b. Then the H field inside the wire for r less than b is, right? So they have given the current density that is carried by a long cylindrical wire whose radius is b, and they are asking us to determine what? To determine the magnetic field, that is H field, inside what? Inside the wire. So how we can do that here? See here, we know that this question is also based on Ampere's law only here. So we know that from Ampere's law, so here I am considering the integral form of Ampere's law, that is the circulation of H field around any closed loop is equivalent to what? Is equivalent to double integral z bar dot what? Z bar dot dA bar. So here they have given a long cylindrical wire. So this is the long cylindrical wire. Okay. So long cylindrical wire means you can assume it as what? You can assume as a cylindrical wire of infinite length. Okay, that's what they mean by long here. It is very long when compared to its radius. Okay, so under that condition we can treat this cylindrical wire as what here? As an as a wire of infinite length, right? Okay. So they have given the current density. What is the current density they have given? This z bar they have given as z a r cube a z cap. So let us consider this is z direction, right? So here the current is flowing in which direction? The current density is in z cap direction, z direction, that is pointing in upward direction. So this is the z bar, right? Okay. So now the radius of this cylindrical wire is nothing but what? B, right? So they are asking a magnetic field inside the cylindrical wire. So if you want to determine, I want to determine the H field at this location here. I want to determine the H field at this location, that is inside the wire. So now what I am going to do here is I am going to consider with this radius here, with this radius r, let us say this radius is r. So with this radius r, I am going to enclose this current distribution with what? With a circular loop. So the current that is penetrating through this surface area is equivalent to what? Is equivalent to the circulation of H field around this closed loop, right? Okay, and here on this surface here, on this circular region, what are the variables here? R is variable and phi is variable. Okay, so if you consider a small differential area on this circular region, so the variables are nothing but what? Here this surface area I am considering as dA, so this dA bar is equivalent to, I can write it as what? R dr d phi az cap. Okay, so this is the small differential area on the surface of this circular region, right? Okay, so this dA bar I can write it as what? R dr d phi az cap. Okay, okay, so we have to determine, I am trying to determine the circulation of H field around this closed loop, right? Okay, so now see here so here the circulation of H field around the closed loop, here what you are going to get? So here you are going to get a closed loop line integral, so that is okay, wait, okay, so closed loop line integral H, so I can write here, so here I am considering H, H field will be in which direction? H field will be in phi cap direction, that is H into a phi cap. So dot this dl bar is nothing but what? Is nothing but R d phi a phi cap, right? So where phi is varying from where to where here? 0 to 2 pi. So this is equivalent to double integral. What is z bar value? Z bar value is nothing but z a r cube az cap dot what? Dot r dr d phi az cap. Az cap dot az cap will become 1. So you are going to get r dr d phi, right? So here the variables are nothing but what? R and phi. So phi is varying from 0 to 2 pi, right? So if you do this, what you are going to get? So here a phi cap dot a phi cap will become what? 1. So what you are going to get? So integral, so I am taking h outside. Okay, so what you are going to get? R d phi, phi is equal to 0 to 2 pi. So this is equivalent to double integral. Okay, so integral, I am integrating with respect to r, so that is ja r cube into r is nothing but what? R power 4 into dr. So integral d phi is nothing but what? Phi. So its range is from 0 to 2 pi. So just substitute all these things here. So what you are going to get? H into, if you integrate this, you are going to get 2 pi r. This is equivalent to ja into integral r power 4 is nothing but r power 5 divided by what? Divided by 5 into, if you substitute the range here, you are going to get 2 pi. So here what you are going to get? So here 2 pi and here 2 pi will get cancelled. So therefore H field is equivalent to what? Is equivalent to ja into, sorry, wait. So here 1 r and here 1 r will get cancelled, so 4 will be left out here. So H field is equivalent to what? Ja into r power 4 divided by what? Divided by 5 ampere per meter. So this is the answer for this question here. Okay, so they have given different options for the question. So the right answer is nothing but what? Ja into r power 4 by 5. So this is the answer. So option D, Ja into r power 4 by 5. So option D is the correct answer for this question. Okay, so these are the two questions they have given in EMT, right? So with this we have completed this EMT topic, right? Okay. So okay, so next some other faculty will engage this session. So I am taking leave. Bye.
of analog as well as control system. So the question which we are going to take, it's gonna be the question number second, which had been the problem from analog circuit. Similarly, in the same sequence, we are going to take the question number 6, which has been based on the concept of operational amplifier. In the same sequence, we would be taking the question number 25. The sequence had been different, no? You need not to focus over the sequence in which you had been experienced the question. Similarly, we would be focusing over the question number 25. Once we are done with the question number 25, we would be taking the question number 27 and question number 40. Yeah. And one of the amusing thing, the 3 questions had been experienced from the operational amplifier side itself. Whereas the electrical branch is being concerned, the analog and digital together makes a single subject. Still, we had got around 5 to 6 number of questions from the analog itself, and among 5 to 6 number of questions, the 3 questions were based on the concept of the operational amplifier itself. So the student who had been appearing in electronics and instrumentation in tomorrow's examination, morning, evening, I would request to all of them, you just have a little bit glimpse of the operational amplifier, because probably for the IIT Kharagpur, the operational amplifier had been a hot topic. Yeah. So let me focus on the first question first. So here comes the first question. Here comes the first question. Let me take this problem to a working board, and we would try to smash that problem there only. So here comes the question number 2. Tell me what was your answer for this given question. Simplest problem. If you guys have a little bit idea about the clipper circuit, definitely you would be able to smash this problem very well. So may I know what had been the best most answer? Tell me what would be the best most answer for this given question. Yeah. In this problem, the statement which has been attached indicates for the circuit shown below with the ideal diode. What does it mean by the ideal diode? That means theoretically it would only be short circuited or the open circuited if it is being operated into the reverse bias and the forward bias. No RF, no RR, no V cut in, no. Everything has been pure ideal. The output will be, my dear friend, just try to understand in this way. If Vin is being applied in such that the upper side the positive polarity and lower side the negative polarity is being applied, in that case the force of current would be from anode to cathode in D1 and similarly anode to cathode in D2. So what would happen? This circuit is going to get intacted. This D1 and D2 is going to be short circuited. If D1 and D2 is going to short circuited, the V in would be straight away transferred towards V0 because the V out and V in is being parallel. If D1 or D2, either of the diode goes into the reverse mode, what happens? The V in would be completely independent from the V out, and in that case the V out is simply going to be 0. V out is simply going to be 0. Is that part clear to all of us? So yes, if you had been applying V in greater than 0, if you had been applying V in greater than 0, what is going to be the state of the diodes? Diode 1, the force of the current is from anode to cathode. The diode 1 is going to be in on state, and similarly the diode 2 is going to be in on state. And as the diode 1 and diode 2 is in on state, what is going to happen? It is going to be ideally a short circuit path. It is going to be an ideally short circuit path. V in is going to come in parallel with R1, and now the V out is being connected in parallel with the V in, and simply I can say if the V in is being greater than 0, V out is being very same as V in. Obviously option A is being a perfect most answer. And as far as the electrical paper is being concerned, there had not been any MSQ, so obviously you need not to search the remaining 3 options. But if you want to focus over the 3 options as well, you can focus on those 3 options as well. See what it states. If V in is been lesser than 0, my dear friends, if V in is been lesser than 0, the force of the current would be in anti-clockwise direction. It is being flowing from cathode to anode. It is being flowing from cathode to anode. Obviously diode 1 and diode 2 would be off, and there V out would be 0 volt. Yes. So if V in is been lesser than 0, V out has to be 0 volt. Similarly, V in is been greater than 0. If V in is been greater than 0, V in is been all the way coming in parallel with the V out, and even the polarity is been matching. Plus is going to get connected with the plus, minus is going to get connected with the minus. So virtually I can say V in out is going to be plus times of V in. And same goes with this scenario as well. When the V in is been lesser than 0, the diodes are being off, and as the diodes are being off, the V in is no more being contacted with the output. Again, the output is simply gonna be 0. Output is simply gonna be 0. Is that part clear to all of us? So this has been the best most answer for this given question. So I think it's been the right time taking the next question as well. So here comes the next question, and that had been question 6 in my PDF. So here comes the next question. It had been the problem from a ideal operational amplifier. May I know what had been the best most answer for this given question? तो मिस मेरे को 15-10 मिनट लगेगा, खत्म हो जाएगा, आप बोल देंगे एक बार, जिनसे भी कोऑर्डिनेट कर रहे हैं आप बोल देंगे एक बार. The problem states the current gain I out versus I in the circuit with an ideal current amplifier given below. The 4 different options are being clearly attached with this problem is being minus of CC divided by CF, minus of CF divided by of CC, CC divided by of CF, and the last option is being CF divided by of CC. May I know what was your answer? What was your answer? I would like to have the input from each one of you. My dear friend, this has been a problem of standard inverting amplifier. You yourself would be able to understand the source had been connected to the inverting amplifier. And as far as this ideal operational amplifier is being concerned, it is not going to sink any amount of current from the inverting as well as non-inverting terminal. As the proper negative feedback is being intacted, virtually speaking, I can say virtual ground effect is going to be true. That means physically if the non-inverting terminal is being connected to the 0 volt, virtually the voltage would be experienced by the inverting terminal, that would be again a 0 volt only. As you can see, there had not been any translation of the current through the inverting terminal, so this I in all the way has to pass through CF only. Yes, so may I know what had been the amount of voltage which is getting dropped across the CF? As the flow of current is being from right to left, definitely the drop of the voltage would be plus towards right hand side and minus towards left hand side. Agreed? So may I know what would be the voltage across this capacitance? Let's take it's been the feedback voltage VF. As the current is been flowing from right to left, I have taken the polarity positive and it has been leaving from negative. So obviously here I had to take plus. The amount of current is been I in, and the impedance which had been offered by the capacitance in Laplace domain is going to be simply equals to of 1 divided by of CF into S. So VF is being clearly known to us, and the VF is been the potential difference between the 2 terminals of the capacitance. May I know what would be the output voltage? You yourself can apply a KVL, and as you had been applying a KVL from this node to virtually ground point, obviously the voltage across this capacitance itself is going to be the voltage across the V0. Yes, and as the positive polarity of the VF has been striking towards the V0, one thing has been quite sure, whatever the voltage had been experienced by this capacitance would be counted as positive. So what is going to be the value of V0? The V0 is being very same as a VF plus of the voltage across this inverting terminal, and the inverting terminal voltage is being 0, so simply it's been a VF. Yes, so whatever the value of VF we had received, no, that is going to be the voltage across this terminal. That is also okay, sir. In the same sequence, if we'll be moving forward, and now we had been focusing over the I0. My dear friend, the voltage across this terminal is being V out, the voltage across this terminal is being 0. So the voltage difference between these 2 terminals is being V0 divided by the impedance which had been offered by the CC. So put together, the current I out is simply gonna be V out. V out is being very same as VF. VF is being I in divided by of CFS divided by impedance which had been offered by this capacitance, and that had been 1 divided by of CCS. 1 divided by of CCS, and in this problem we had to calculate the current gain. So I out remains as it is, I in goes towards this side, and end of the day we get the current gain, I out versus I in, and that had been, see, S and S part is going to go off, and similarly I in is already been brought towards left hand side. C of C would go towards the upside, and C of F would go towards the downside. So the student who had got this answer invert, that has been the wrong answer. The student who had got the minus sign, that has also been the wrong answer. So the best most answer for this given question is been option C. this given option has been option C. Is that part clear to all of us? So C has been the best most answer. I think it's been the right time. Taking the next question as well. So here comes the question number 25. Let me straight away hop into the question number 25. तो मिस कौन आ रहा है इसके बाद? ठीक है. A simplest problem. The student who had a little bit idea about the saturation of operation amplifier definitely must have conquered this problem easily. So let me bring this problem towards working board and we would try to smash this problem out. So here comes the next question. The problem states the steady state output V out of the circuit shown below will be. The options are being saturation 2 minus VE, saturate 2 plus VDD becomes equals to of minus 0.1 volt become equals to 0.1 volt. May I know what would be the best most answer for this given question? My dear friend, just try to understand in this way. At very beginning, when the output is being kept at 0, negative feedback is being properly intacted. So obviously the virtual ground theory is going to be true. And as the virtual ground theory is going to be true, with the help of potential difference between these two terminals, you can easily find how much current is being experienced by this resistance R1. Yes sir, we can understand that. So this has been at positive potential, this has been at ground. So obviously the amount of current which has been flowing through this branch would be from left to right, and the amount of current which has been flowing is being 1 volt divided by of R1. Being an ideal operational amplifier, it is not going to translate any amount of current through the inverting as well as non-inverting terminal. Either it had been in saturation region, either it's been in linear region. In either of the cases, it is not going to sink any amount of current. So all the way, all of the current had been passing through this capacitance itself. And you must be knowing about it. Anyways, if you want, I can give a little bit derivation sort of thing. Whenever a constant current source is being applied across a capacitance, that used to be a linear charging of case. That means the voltage across the capacitance would be keep increasing linearly. And may I know what would be the polarity over here? The polarity is going to be positive as the current is being entering to the passive element, and as it has been leaving from this terminal, it is going to be negative. It is going to be negative. Yes. Yes. May I know what would be the rate of charging? You can simply write this as current across the capacitance is being defined as a dV by of dt. In this problem, IC has been a constant value, so the V is being simply equals to of integration of IC dt, and that is going to be IC into T. IC into T. So as the time is been lapsing, this has been keep charging with the worth of ICT, and after certain amount of time, what would happen? Do you know that? The output voltage V out is been very same as minus of VC. And as the output voltage goes beyond minus of VEE, minus VEE goes beyond minus VEE. So from the characteristic of the operational amplifier, you can easily say the output saturates. You can easily say the output saturates. So may I know what had been the best most answer? The best most answer has been minus VEE. If in this problem, rather taking 1 volt polarity upside positive, downside negative, they must have been reversed this polarity, no? In that case, the direction of the flow of current must have been reversed. In that case, the polarity of the voltage which has getting charging this capacitor must have been positive this side, negative this side. And as it has been keep moving, after certain amount of time, the voltage across the capacitor must have gone beyond VDD, and in that case, the output would get saturated at plus VDD. Did you understand what I am saying? So as far as this problem is being concerned, the best most answer has been A. In the same sequence, I think it's been the right time taking the next question as well. So here comes the question number 27. Yeah. Here comes the question number 27. One of the easiest problem from the control system. So the student who had a little bit idea about the block diagram reduction and the second order system definitely must have cracked this problem well. basically we had the two standard negative feedback system. We had to solve, we had to find its characteristic equation. By comparing the characteristic equation into the standard form of the second order characteristic equation, we will be able to get the value of omega n, we will be able to get the value of zeta. Tell me what would be the best most answer over here? What would be the best most answer over here? First focus over this part. It had been the standard form of the negative feedback system with the feedback transfer function is equals to 1, or I can say negative UFB system. So the gain offered by this block is simply going to be forward path transfer function that had been 10 divided by of s divided by of 1 plus forward path transfer function into the backward path transfer function, or I can say the loop gain 10 divided by of s into 1, that remains 10 divided by s. So this factor has been simply equals to of 10 divided by of s plus of 10. 10 divided by of s plus of 10. This part must be clear to all of us. Now what had been happening, this block is going to be connected to the 10 divided by of s into the cascading fashion. So what had been happening, 10 divided by of s plus 10 gets multiplied with the 10 divided by of s. So put together this has been 100 divided by of s into s plus 1. And here my basic intention is not to get the complete transfer function. We had been just been focusing over the what characteristic equation, and how the characteristic equation would be calculated. Just focus over this complete forward path transfer function. Yes, that had been GS. And what would be its characteristic equation? It would be 1 plus GS into HS. HS has been again 1 and can be easily compared with 0. And once we do so, it becomes S square. Then here it goes. Here it goes. How much? Tell me how much answer we had been getting. 10 has been there, no? Just a minute. 10 has been there. S square plus of 10 of S plus of 100 is equals to 0. Is equals to 0. Now I think it's been the right time comparing this characteristic equation into the standard form of the second order's characteristic equation, which has been s square plus of 2 zeta omega ns plus of omega n square. Omega n square has been compared with 100, and easily we would be able to get the value of omega n, and the value of omega n which we had been getting, it's been root over of 100, and that had been 10 radian per second. Yeah, and as far as this term 10 is being concerned, it had been in place of 2 zeta omega n, and that had been 10. 2 into 10, that's been 20. The zeta is going to be 10 divided by 20. The value of zeta is simply going to be 0.5. So as far as this problem is being concerned, the value of zeta is being 0.5, and similarly the natural frequency of oscillation which would be provided by this system is being simply 10 radian per second. So this has been the best most answer. Whoever have given this answer, so definitely that had been the best most answer. In the same sequence, the next question do come in front of us. So yeah, this has been the question based on the concept of vector calculus, and this problem basically focuses over the concept of gradient. Anyways, you must be knowing this fact. The gradient is always been applied over the scalar quantity and results the vector quantity. And the vector quantity used to have the two components. The first used to be the magnitude, and second used to be the direction. The magnitude talks about the maximum rate of change, and similarly the direction has been the direction at which the maximum rate of increment is being taken place. Yes, so focus over this problem. The function, yes, it has been a scalar function. The direction of f increases most rapidly at point P is equals to x is equals to 1, y is equals to 0, and z is equals to 2. This has been the problem of gradient. So you had to perform the gradient over the scalar field f. Dot could not be there, no? Gradient of f. Gradient of f. So what had been happening, partially this complete scalar function would be differentiated with respect to the x, and that would result 8 times of x, and this component would fall in the direction of ax cap, plus partially the complete function would be differentiated with respect to the y, so the factor which has been left out is been simply 7 of x, and this component would fall in the direction of ay cap. To miss bol ek bar, ye last question. And similarly the last differentiation would be taken place with respect to the z, and that had been 3 times of xz. 3 times of xz, and let's start feeding the data over here. The x would be fed as 1, y would be fed as 0, and z would be fed as 2. So let me start feeding the data over here. So as we feed x as 1, so the factor which we get over here, it's been 8 times of ax cap, and similarly here we get 12 times of az cap. Probably there could be certain discrepancies over the question, but the concept remains very same. May I know, is there any discrepancy somewhere? But whoever have followed this sequence, they must have got the same answer. So as far as this problem is being concerned, this problem is being based on the concept of gradient. First we have to perform the gradient of this scalar function at point 1, 0, 2. Is that part clear? So now I am going to hand over the session to the, please sir.
So good evening everyone. Sound clear है ना? ठीक है. So now we will discuss the questions of power electronics. So this one is the first question. It is that single phase full bridge diode rectifier fits a resistive load of 15 ohm from 200 volt 50 hertz single phase AC supply. If the diode are ideal, then active power in watt drawn by the load is, ठीक है, blank space watt. क्लियर है? तो ये तुम्हारा वाट में आप लोग का जो क्वेश्चन है उसको ये पूछा हुआ है. क्लियर है? ठीक है. तो इसको डील करते हैं. क्वेश्चन है बहुत ही आसान क्वेश्चन है ये. ठीक है. ये आपका सिंगल फेज फुल ब्रिज डायोड रेक्टिफायर फिट्स रजिस्टिव लोड. तो ये तुम्हारा सबसे पहले आप लोग को देखना है, यू हैव टू सी दैट सिंगल फेज फुल फेज ब्रिज डायोड रेक्टिफायर ना. तो सिंगल फेज फुल ब्रिज डायोड रेक्टिफायर, तो सिंगल फेज फुल ब्रिज डायोड रेक्टिफायर सर्किट डायग्राम इज दिस वन. दिस इज योर सिंगल फेज फुल वेव bridge diode rectifier with resistive load. So here we have a resistive load of how much? 50 ohm. This is your 50 ohm. ठीक, we have got 4 diodes 1, 2 and 1 2 3 4, D1, D2, D3 and D4. Okay, and here we have got input DC, input AC. So here we have input AC. So this is our input AC, and that is how much? 200 volt and 50 hertz RMS. So this is 200 volt 50 hertz. Okay, 200 volt 50 hertz. Clear? Now the power drawn by the load, active power drawn by the load. Okay, so see, okay, try to solve it. बहुत ही आसान क्वेश्चन, इट इज नॉट दैट टफ क्वेश्चन ना. सो वी नो दैट आउटपुट वोल्टेज वेवफॉर्म इज हाउ मच? हाउ विल गेट द आउटपुट वोल्टेज वेवफॉर्म? सो this is our output voltage waveform V0. So V0, in this case we will get this one. So this is our output voltage waveform. So 0, pi and 2 pi. Clear? 2 pi. This is our VM. Okay, this is our output voltage waveform. Okay, VM. So now the power P is equal to, for resistive load, the power dissipated for resistive load is V0 RMS square divided by R. So this is your answer. P is equal to V0 RMS square by R. And here how will get the RMS value? RMS value of output here. RMS value of output here V0 RMS is same VM by root 2. Okay, value of RMS is VM by root 2, and that is input RMS value. So RMS value is already given 200. So here peak value VM is equal to 200 root 2. Okay, 200 root 2. So this is the 200 volt is RMS. RMS means here we have got this one 200 root 2. 200 root 2. So this is your input, and this is what you are getting output in DC side na. So this is your output voltage. So 200 root 2. So RMS value V0 RMS is equal to 200 root 2 divided by root 2, and now we got 200 volt. Okay, 200 volt. So this is our V0 RMS. So now the power P is equal to V0 RMS square. So V0 RMS square divided by R, that is 50. So what we got? We got 800 watt. We have got 800 watt. So here answer is your 800 watt. Okay, answer is 800 watt. Okay, answer is 800 watt. Clear? So this was very easy question, not that tough na. Answer is 800 watt. Clear? What will be the cutoff and what will your experience, please? 75 is, I think so you have to score not much from the 75 is good for PSU. You can get interview call na. But I think question was easy na, so question marks you need around 18 plus for the PSU. That is my observation na. Otherwise it can change. So this is 800 watt. Simple question, not that tough na. Directly you have got RMS value is 200 root 2, means basically 200 volt square divided by 5. So this is your how much? 800 watt. So 800 watt is answer here. Simple question. Okay. So next one is so first we will do easy question na, then we will go for tough question. So this is our next question. A charger supplies 100 watt. Okay, a charger supplies 100 watt at 20 volt for charging the battery of laptop. The power device used in converter inside the charger operates at switching frequency of 200 kilohertz. Which power device is best suited for this purpose? Okay, this is very good question. Here it is asking that is asking 100 watt and 100 volt and 20 volt. 100 watt and 20 volt. So this is basically low power application. Low power application. Okay, low power application. A charger supplies means our laptop charger, that is 100 watt at 20 volt. So it is low power application for charging the battery of the laptop. The power devices used in converter inside the charger operates at switching frequency of 200 kilohertz. So this is your switching frequency, operating frequency. So this is our operating frequency, operating frequency, operating frequency. Which power device is best suited for this purpose? So first of all, here given frequency is 200 kilohertz. Okay, so this is your mid-range frequency, and for mid-range frequency our MOSFET, okay, thyristor is not, thyristor is wrong, because thyristor is used for high power and low frequency, so thyristor is wrong. Okay, then you have got MOSFET and IGBT. So this range MOSFET and IGBT both can be used, MOSFET and IGBT both can be used, but among MOSFET and IGBT, MOSFET is better suited for this particular operation, because MOSFET is highly efficient for low power. So MOSFET is good for this frequency. So answer would be 200 for 200 kilohertz. In this low power, because of low power we will use MOSFET. But if the power were high, like instead of 100 watt, if you in this question, instead of charger laptop, it is given that it is driving a traction load like Vande Bharat train, 18 which is used, in which we use IGBT as a switch. Okay, so for high power devices we use IGBT, for low power devices we use MOSFET. Okay, MOSFET. In frequency range of MOSFET, operation of MOSFET is somewhat higher than that of IGBT. Okay, so MOSFET operates at higher frequency compared to IGBT, but IGBT is used for higher power application, but MOSFET is used for low power application. So here the power is 100 watt and 20 volts. So this is low power rating, and because of that we are using MOSFET. Okay, so MOSFET is correct answer here. Okay, so let's go to the next question. So this is our next question. For an ideal AC to DC rectifier circuit shown in figure below, the load current magnitude is 15 ampere and ripple free. The thyristor are fired with a delay angle of 45 degree. The amplitude of fundamental component of the source current in ampere is. Okay, so here this is your semi converter. So first of all, that rectifier circuit is semi converter. This rectifier circuit is semi converter. Rectifier circuit is semi converter. Okay, rectifier circuit is semi converter, and it is showing that this current is how much? This current is 15 ampere. This current is 15 ampere. This current is 15 ampere. Okay, so this is our semi-conductor circuit, and this current is 15 ampere. Okay, so here this is the amplitude of fundamental component of the source current. So this is our source current. So source current waveform will be like this. So for semi-converter, source current waveform will be like this. Source current waveform will be like this. Source current waveform will be like this. Okay, so this is our 15 ampere, and this is our minus 15 ampere. Okay, 15 ampere, and this is our minus 15 ampere, and this is our 45 degree. Okay, so this is our source current waveform. So for this source current waveform, the Fourier analysis, this is our ISN, waveform of IS. So ISN will be 4 summation of n is equal to 1, 3, 5, an odd number, infinite, 4. This is our IDC. So 4 into IDC upon n pi cos n alpha by 2, then sin n omega t minus n alpha by 2. Okay, so this is our expression. So here if I want the amplitude of fundamental component, so IS1 is equal to how much? 4 into IDC is 15 ampere, n is equal to 1, pi into cos 45 by 2. Okay, so this is our fundamental peak value. By solving this, how much you will get? By solving this, you will get, this is how much you will get, 17.83 ampere. 17.83 ampere. Okay, this is our like 17.83 ampere. So here in question, the fundamental component of source current is asking. Now he is asking fundamental component of source current, so I am considering it peak value. This is our peak value. Okay, this is our peak value, but in question it should have mentioned that he is asking peak value, because that fundamental component of source current could have either peak value or RMS value. Okay, or even in fact it can have also average value. So average value definitely will be 0, but since it is not mentioning, so here you can say that there is a kind of ambiguity in this question, but answer is here 17.83 ampere, and this is our peak value, 17.83 ampere, and it is our peak value. Okay, 17.83 ampere, and this is our peak value. Clear? So this is our question. Okay, then go to the next question. So again I'm going up na. I'm solving tougher question early. So easy question early. So now this one is done from top. So now we'll solve this question. So this is third important question. So here the voltage at output of AC to DC rectifier is given by Vt 200 root 2 sin omega t, where omega is equal to 2 pi into 15 radian per second. The input current drawn by the rectifier is given by this much. It is equal to 10 sin omega t minus pi by 3 plus 4 sin 3 omega t minus pi by 6 plus 3 sin 5 omega t minus pi by 3. The input power factor round up to the 2 decimal places is blank space lag. Okay, so this is very basic question. Very basic question. Okay, so not that tough. So you can simply solve it. Very basic question. So how much is power factor? So power factor by definition is power delivered divided by VSR into ISR, RMS input into voltage. So this is your power factor by definition. So here power delivered is how much? So input power, here we have got frequency component of voltage omega t and current omega t. Okay, so power delivered is how much? Power delivered is 200 root 2. So power delivered P average into, so power delivered will be how much? VS1 RMS into IS1 RMS. So this is our power delivered divided by VSR into ISR. Okay, ISR. So this is your power delivered. So power delivered is only done by fundamental component. So this is your fundamental component, this is your fundamental component. So power delivered is 230, because this is RMS. So fundamental component only here 230 into current is how much? 10 by root 2. Current is 10 by root 2. So this is your peak value. I am considering RMS value, so 10 by root 2 divided by VS. So VSR is how much? Same, 230 into ISR. The RMS value of this one would be RMS value would be RMS is equal to would be under root 10 by root 2 square plus 4 by root 2 square plus 3 by root 2 square. So this will be upon our RMS value for this particular current. So if I am putting this RMS value here, so here I have got, this is 100 by 2 plus 16 by 2 plus 9 by 2. Okay, by solving this equation, how much we will get? In here there is also phase difference na, so there is a pi by 3, so here cos pi by 3 also, cos pi by 3, so here power factor cos phi 1. So by solving this I will get how much answer? 0.4476. So this is our power factor and it would be lagging, So this is your power factor 0.66. So power factor is 0.4476 and it is lagging. It is very easy question. Okay, I'm just trying to solve it as long as possible because I want to explain that here from this current you are getting this RMS value and the power delivered to the load is only fundamental component. So here fundamental component is omega t and here fundamental component is this current only. So for power delivered I am only considering this voltage and this current and multiply by their phase difference. So cos of phi. Okay, so cos of phi 1 you can say that because this is for fundamental. So phase difference between voltage, fundamental voltage and fundamental current is pi by 3, that is cos 60. So cos 60 would be 1 by 2 and this is your RMS source voltage and this is your RMS source current. So RMS source voltage is directly given 230, okay, into RMS source current is you have to calculate by using this method na? So you'll get 0.4476. So 0.4476 is answer here. Okay, so now I'm going to the next question. 0.4476. okay. This one is, so now this is our next question. Consider an ideal full width single phase DC to AC inverter with DC bus voltage magnitude of 100 volt. The inverter output voltage Vt shown below is obtained when diagonal switches of the inverter are switched with 50% duty cycle. The inverter feeds a load with a sinusoidal current given by It is equal to 10 sin omega t minus pi by 3 ampere, where omega is equal to 2 pi by t. The active power in watt delivered to the load is, okay, so here in full width single phase DC to AC converter, DC to AC converter, so this is our output side, DC to AC converter, so this is our output side. So this is our voltage. So first of all here we have got DC input voltage na? So voltage magnitude is 100 volts. So basically this one is your 100 volt, sorry 1000 volt, and this one minus 1000 volt, okay, 1000 volt and minus 1000 volt here, 1000 volt. Now current that flowing lags pi by 3 and magnitude is 10 ampere and that is sinusoidal. So current that is flowing is lagging it by pi by 3 and it is sinusoidal. So this is our pi by 3, that means 60 degree, okay, 60 degree. So this is our current magnitude. So peak magnitude will be 10 ampere, peak magnitude would be 10 ampere. So now the active power in watt delivered to the load. So this is your output voltage at the load and this is your output current at the load. So this is your output voltage and this is your output current. So if I want to, this square wave will have fundamental components and that fundamental component V and T would be 4 into 1000 divided by n pi n sine n omega t, okay. So among this value I have to consider only fundamental. So fundamental value of output voltage V1 T would be how much? 4 into 1000 upon n pi into sine n is equal to 1 here, so only pi into sine omega t, okay. So RMS value of V1 T, RMS value V1 RMS is how much? Divide by root 2. So this is peak value divided by root 2. So 4 into 1000 divided by pi by root 2. So here I will get 2 root 2 by pi into 1000. Then here I will get answer of 900 volt because this is 0.9 and I have got 900 volt. Okay. Now the power is how much? Power delivered to the load. So power delivered to the load, that would be fundamental only because you have got voltages of different value. You have got fundamental in third harmonics and fourth harmonics and all, okay. But in output current you have only this one. Now this one is given. So here the power delivered would be how much? Power delivered would be VRMS, V not RMS, you can say that V not RMS, VAC RMS into I RMS into cos of their angle difference. So angle I am writing just cos phi na. So here V not RMS is how much? 900 volt. So 900 into I not RMS is given 10 by root 2, so that is peak value. So 10 by root 2 into their phase difference. So phase difference is how much? Pi by 3 means 60 degrees. So this is cos 60. If you solve this, you will get how much? You will get answer 3183.09. You will get answer of 3183.09 watt. So here answer is, you can also write in, it is asking in watt na. So answer is your 3183.09 watt. Okay, so this was also easy question. So I'm going to the next question. Okay, so this one is also done. One tough question from the chopper na. I will discuss this one. Actually this one is the most toughest question of the power electronics. So it is basically given the steady state current flowing through the inductor of the DC to DC buck boost converter. So he is saying that this is your buck boost converter. This is your buck boost converter. Okay, buck boost converter. This is our buck boost converter. Converter is given in the figure below. If the peak to peak ripple in output voltage is 1 volt, then the value of output capacitor in microfarad is. Okay, so here it is giving peak value voltage ripple and is asking your capacitance value of capacitance. Okay, so this is your buck boost converter. Buck boost converter. So here buck boost converter is typical way. Actually in all the converters, buck boost and buck boost converter, we all know that buck boost converter is somewhat tougher than in the other two converters. So in buck boost converter, the inductor current, this inductor current, part of this inductor current is source current. In buck boost converter, part of this inductor current is source current. Okay, so part of this inductor current is your source current. So here out of this total current, only this one is your source current. So this one is our source current, so it is 0. Okay, I am writing it in white line. So this is our source current only. This is our source current. Okay, our source current. So here we have got 12 ampere and we have got here 16 ampere. So this is our source current. Okay, source current. This is our time in microsecond, and this total time is our 20 microsecond. Okay, now I have to calculate, this is our IS na, this is our IS. Now I have to calculate IS average, the average value of this current, IS average. So now I have to calculate IS average. So IS average will be how much? This total time period is 15, so total this is also 30, then again it will start same, behave like this, same. Okay, so total time period is 50. So for IS average 1 by 50 total time period into this total area. So this, how much is this total area? This total area is 12 into 20 plus 1 by 2 into 4 ampere. Okay, so this is 50. By solving this, how much I will get? IS average would be 5.6 ampere. 5.6 ampere. So IS average would be 5.6 ampere. Okay, 5.6 ampere. Now I have to get IS naught, I naught. Okay, I naught. So here what is happening in your converter? In converter we have here VS, source voltage, and we have here our source current. Here what we are getting? Here we are getting output voltage. Okay, this is our output voltage and this is our output current. So by power balance equation, VS into IS is equal to V naught into I naught. So both are equal. V naught is equal to I naught. So by power balance equation, same input power is VS into IS and output power is V naught into I naught. So all are average values na, all are average value. So VS value is how much? VS we don't know. Okay, VS we don't know. So IS is how much? IS we know, that is our 5.6 ampere. 5.6 ampere. And also 5.6 ampere, and also V naught we can write in terms of Vs. So that is alpha 1 minus alpha into V naught into Vs into I naught. Okay, so Vs got cancelled. So I naught would be how much? I naught would be 5.6 into 1 minus alpha by alpha. Okay, so now here the duty cycle alpha is equal to T on by T. So this is on period. We know in buck boost converter this is our T on. So T on is our 20 microsecond divided by total is 50 microsecond. So we have got 0.4. So if I put value here of 0.4 here, I will get I naught is equal to I will get 8.4 ampere. 8.4 ampere. So this is our I naught. Okay, so now I have got I naught. I have to calculate capacitance C. Okay, in microfarad. Capacitance C in microfarad. So capacitance C, we have one more formula for capacitance, that is del Vc. We know in buck boost converter del Vc is equal to alpha into I naught upon F into C. Alpha into I naught upon F into C. Now I've got all the values. Del Vc is given, that is 1 volt, and F we can calculate. Here total time period is 50 milliseconds. So here we can get F na F. F is equal to 1 by T. So 1 by T is how much? 1 upon 20 microseconds. So we'll get 50 microsecond. So this is total time period is 50 microsecond. 50 microsecond, we'll get 20 kilohertz. 20 kilohertz is our frequency. So if I put value here, C is equal to alpha is 0.4 into I naught average is 8.4 divided by del V is 1 into frequency. Frequency is how much? Just I have calculated 20 kilohertz, 20 to the power 3. By solving this, I will get C value 168 microfarad. So this is our capacitance C. Okay, so this is our capacitance C. So the value of capacitance would be 168 microfarad. Okay, 168 microfarad. So it is asking question. In question it is mentioned that he is asking value of capacitance in microfarad. So you will write only 168 directly. Okay. So this is your toughest question in this particular paper, when someone can argue about this solution, because in someone will say that you can directly calculate the value of I naught, okay, by simply doing this. Now someone will do that 16 plus 12 divided by 2, and he will say that you will get directly value of I naught, but that is not applicable for the buck boost converter. Okay, buck boost converter, this is your waveform of the IS. You calculate average value of this IS. You just use power balance equation, you will get average value of I naught, and by that value of I naught you will get the del Vc, and from this formula we will get the capacitance, that is 168 microfarad. Okay, so the value of capacitance is quite high for this particular question. Okay, so now we have got last question. So this is our last question. A 3-phase grid connected voltage source converter with DC link voltage of 1000 volt is switched using sinusoidal pulse width modulation. Okay, sinusoidal pulse width modulation. If the grid current is 10 ampere, and the 3-phase complex power supplied by the converter is given by minus 400 minus J300 volt ampere, then modulation index used in sinusoidal PWM is. Okay. So this is again typical question, and nowadays the GATE is asking in GATE now every year we will get one question from the PWM topic na, PWM topic. So now this year is not asking from the voltage source and current source inverter, they are asking from the pulse width modulation. Okay, pulse width modulation. So here given, what is given, you can again, this question can also be solved by many methods, so I'm just solving by one simplest method. So here it is given that the total power S is equal to minus 400 minus 4000 minus J 3000 volt ampere. Okay, now this is real imaginary part, so obviously answer is negative. So what is saying that 3-phase grid connected voltage source converter with DC link voltage of 1000 volt is switched using sinusoidal pulse width modulation technique. So we have got DC grid to AC grid. ठीक है ना, AC grid. So here we are getting this much power. Here the current, the phase current, I phase in AC, I phase is how much? 10 ampere. I phase is 10 ampere. And the 3-phase complex power is supplied by the converter. So basically what is happening, this power, AC power is negative now. Means actually technically what is saying that it is just supplying, AC is supplying power to the DC grid. But in question he is just saying you that the DC grid is supplying power to the AC grid. But ultimately the power is negative, means direction of power is opposite. So in actual case this AC power is transforming to the DC power. Okay, so it does not matter, you know that. We will just solve this question by using pulse width modulation, but I am just telling you that because of this negative value the power is actually flowing in opposite direction. So power is going from AC to DC. So here the modulation index used in PWM. So he is asking for the modulation index MA. Modulation index is asking how much is modulation index. Okay, so here DC link voltage is 1000 volts. So let's solve. In AC side, here fundamental component of phase voltage, and that is peak na. Peak phase voltage is how much? Fundamental component of peak phase voltage is M into VDC by 2. M into VDC by 2. So this is our fundamental value of the peak. Now the line peak voltage would be root 3 times of this value. So M into root 3 VDC by 2. Okay, so that would be root 3 times of this value. Then after RMS value is how much? RMS value is M into root 3 VDC by 2 divided by root 2. So this is our RMS value, V1 RMS. Okay, so now power is given na. So power is given, so S is your 400 minus J 300. So I can write this one, S is equal to basically under root 4000 square plus 3000 square, and by solving this I will get 5000 volt ampere. So my answer S would be 5000 volt ampere. So now I will use this value. So this is actually 3-phase power na. So 5000 would be equal to root 3 times of this value. So this is your line value na, would VL into IL. Okay, so by default we consider it as star. So current, phase current is 10 ampere, so star in phase and line current both have same. So here answer is root 3 into line voltage. Line voltage is M into root 3 divided by 2 VDC by 2 into IL, and IL is how much? 10 ampere. IL is how much? 10 ampere. If I solve this question, the value of M would be, VDC is here how much? 1000 volts. So we can replace that value VDC with 1000 volt na. You have got no problem, just write it here, 1000 volt. Okay, 1000 volt. By solving this we will get the value of MA would be, by solving this we will get value of M, or M would be how much? That would be root 2 by 3, and that would be equal to 0.4714. Okay, 0.4714. So here your modulation index is 0.4714. Okay, so these are all your questions from the power electronics. So it has got completed. So now I am handing over this session to Venu sir. Okay, thank you.
Okay, hello everyone. Already we have discussed question from digital electronics and network theory. 3 good questions from network theory we have discussed. All the question was easier. 2 more question and 2 questions asked from the resonance. So 2 question has been asked from the resonance. Okay, and again both are very easy question. Okay, but in one question definitely there are some concept is required. So now next question I am going to take. Okay, next question I am going to take from the from your network theory, and this question is from the resonance. So in this question one LC network is given. This is your pure capacitor, but here this is a lossy inductor, or you can say coil is given, and this is C, this is L, and this is R. Okay, they have not provided the value here, just one capacitor, and this is a pure capacitor you can say, and one lossy inductor are connected in parallel. And in this question a resonant frequency is provided, and that is in hertz. So this F0 was given, and F0 was, this is 150 kilohertz. This F0 was given, this is 150 kilohertz, and bandwidth is also given, and bandwidth is also given here. Bandwidth is in hertz also. This is 600 hertz. And now in this question examiner asks the quality factor of the network is. So what is a quality factor? Quality factor of the network is. So in this question they have asked quality factor of the network. This is a very basic and very easy question, very easy question. So in mind you can also handle. So in this question you can say this F0 is given in hertz, and bandwidth is also given in hertz, and we know very well what is a formula for quality factor. And this is nothing but resonant frequency. Resonant frequency divided by bandwidth. But here you have to concentrate. If you are considering resonant frequency in hertz, you have to again consider bandwidth in hertz. So here both is given in hertz. So this is nothing but 150 kilohertz divided by, this is nothing but 600. This is 600 hertz. So here you will get, now you can cancel out. So you will get from here 15 divided by 600, 60. So you will get this K, I can write, this is 1000, and 15 and 16 will be cancel out. You will get divided by 4. So 100 by 4. So quality factor is nothing but 250. So here this question was a numerical answer type question. The question was numerical answer type question, and this was for 1 mark question. Okay, this was a 1 mark question. So in this question, in bracket, just you have to put 250. So your quality factor is 250. I hope definitely everybody has solved this question in GATE exam. Just confirm me, have you attempted this question or not? So one more question is left. Okay, now the last question from the network theory. 5 question has been asked from the network theory. Okay, so next question I am going to take. From the network theory. So, and this is a good question. In this question, what exactly examiner have provided? They have provided quality factor of inductor is provided, and quality factor of capacitor is provided. So now in this question, quality factor of inductor is provided, this is 60, and quality factor of capacitor is provided, this is 240. And now they said this inductor and capacitor are connected in series. So here we have one element. Here the element was inductor. And here the element was capacitor. And now these two are connected in series. So now they have given this inductor and this capacitor. This inductor and this capacitor are connected in series. Then you have to find out overall quality factor. So you have to calculate here. You have to calculate for this overall quality factor. So Q you have to calculate. Here for inductive circuit quality factor is given, and for capacitive circuit here quality factor is given. So what will be, you can say, effective quality factor or Q, anything you can write. So you can write here what is effective quality factor, or you can also write Q. So here one important thing, sir, if quality factor is given, what do you mean by this? So if a quality factor is given across inductor, it means this is lossy, it means this is a lossy inductor, it means this is a lossy inductor, and again this is a lossy capacitor, again this is a lossy capacitor. So sir, how we can represent, to lossy inductor and a lossy capacitor? So lossy inductor is represented by one resistor having one series inductance value, and this generally you can say this is nothing but a practical coil. So here if I am going to assume this value is R1, and here suppose this inductance is L, so here quality factor you know very well. So quality factor for this I can write QL is nothing but you can write omega L by R1. So here this is nothing but omega L by R1. Similarly, sir, what is lossy capacitor? So this is very important thing. What you will assume here, lossy capacitor. This is very important thing here. So some student can assume lossy capacitor as a capacitor having parallel resistance, and here this is you can say C, and you can say this value is R2. This is very good question, and some student can also assume here, sir, one resistor and one series capacitor like this. This is your R2 and this is C2. This is R2 and this is C2. So now the important thing which we have to assume. So here definitely examiner have to provided which kind of capacitor you have to assume in this question. So but this was a 1 mark question. Okay, this was a 1 mark question. And again this is a NET question. So here at least examiner have to provide it. We have to here consider this capacitor or this capacitor, but definitely if you will consider this capacitor, our calculation and solution will be very lengthier. So we cannot handle this question within 5 minutes, or you can say within 10 minutes. So definitely we have to go with this one, and definitely examiner will also go with this one. So here this inductor and capacitor are connected in series. So here what we are going to assume, this is the capacitor and this is the inductor. So sir, what is here quality factor for capacitor? So quality factor of capacitor we know very well, 1 upon omega R, and here this is R2 into C. Can I say 1 upon omega R2 into C? So now this inductor, this is complete inductor, this is a complete inductor, and this is a complete capacitor. So now these two if are connected in series, then what will be the effective quality factor? So here you can see if we will connect here, sir, one resistor and one inductor. This is a lossy inductor, or you can say practical inductor, and here one resistor and one capacitor. So here this resistance value is R1, this is L, this resistance value is R2, and this is C. So sir, what is this quality factor? So you can write either you can say, sir, this is quality factor effective or Q. So what we can write? So here two formula you can use. Now this is a RLC circuit. So now can I say, sir, now this circuit you can say this complete R is here, this complete R is nothing but sir R1 plus R2, and you can say this R equivalent. Can I say? And sir, here inductance value is L and capacitance value is C. So here quality factor what we can write? So this is basic series RLC circuit, and for series RLC circuit we know very well. So this you can write, sir, omega 0 L by R, or you can also write sir, this is nothing but 1 upon omega 0 RC. So any formula we can use, but here, sir, which R you have to consider? This R. So this is a R equivalent, or this is a R equivalent, or this is R equivalent. And here frequency is operating frequency is resonant frequency, and here operating frequency is a resonant frequency. So here what we can write, this R equivalent can I write? This is omega 0 L by this R is nothing but R1 plus R2. And from here if I will divide 1 upon omega 0 L from here, so this is nothing but R1 by omega 0 L plus here this is R2 by omega 0 L, R2 by omega 0 L. Now come to the previous one, sir, can I write here omega 0? Can I write here omega 0? Yes, sir. Because quality factor generally we use at resonance frequency. So this you can also write here. This you can also write. This you can also write. Omega 0 is nothing but sir 1 upon root over LC. We know this thing. And similarly, sir omega 0 square we can also write 1 upon LC. So from here, sir omega 0 L I can write 1 upon omega 0 C. 1 upon omega 0 C. So this 1 upon omega 0 C, sir, can I write this is nothing but omega 0 L. So this is nothing but omega 0 L by R2. So this quality factor across the capacitor is nothing but omega 0 L by R2, and quality factor across the inductor is QL is omega 0 L by R1. So now come to this derivation. Come to this derivation, here you can get, so this value you can write, this is nothing but 1 upon, this is nothing but 1 upon quality factor for inductor plus 1 upon, okay, this R2 by omega 0 L, or you can say omega 0 L by R2. Can I write quality factor for the capacitor? You can see here omega 0 L by R2 is nothing but quality factor for the capacitor. So if you will solve this, what you will get from here, this QL plus QC by QL QC. So from you will get QL into QC divided by QL plus QC. QL plus QC. Many students directly remember this formula if they studied this thing. So what is a sir effective quality factor? Or you can say Q of the whole circuit. This is a inductor quality factor and capacitor quality factor divided by inductor quality factor plus capacitor quality factor. So if anybody remember this direct formula, you can put the value here. Okay, so this is nothing but one kind of parallel combinations of quality factor. Some students remember directly like this. If inductor and capacitor quality factor is given, so just you can apply the basic your parallel combination formula for the quality factor. QL QC divided by QL plus QC. Some students remember first quality factor inverse plus second quality factor inverse and whole answer inverse. Okay, so now you can put the value here. This QL was given 60 and this QC was given 240. So here 60 plus 240. So from here we will get a 60 into 240 divided by this is 300. 300. So what will be the answer here? Sir, this 0 and 0 will be cancelled out. 1020 will be cancelled out. This is a 3 and this will cancel out 8. Okay, now 8 into 6, this is 48, or this 3 into 6 you can cancel out. 24 into 2, you are getting here 48. So quality factor effective, or quality factor you can say effective, or you can say quality factor of the combination of inductor and capacitor, we are getting 48. This is numerical answer type question. This is numerical answer type question and you have to put answer here 48, and this question is for 1 mark. So if this is a 1 mark, means examiner want you should know directly this formula and directly you can put the value here. So this was I can say here one mistakes from the examiner side. They have not mentioned here, sir, this capacitor are connected in parallel or in series. So maybe you can be trapped in this question. And if you have studied this, so easily you can handle this. Okay, so just I have taken from my side in our global channel. Okay, in this channel 2 questions from the digital and 5 number of questions from the network. Okay, so everybody just comment one time. Okay, so have you enjoyed this session? And you have to compare your result, your answer, okay, with my answer. Okay, so according to me, all the network question was easier except this question, and digital question was very easier. So according to me, if you are a good student, so I hope definitely you will get more than 70 to 75 marks. Okay, so everyone, so now my session is going to be over, and now the next session is going to be start, okay, within 8 minutes. Okay, so thank you, and again best of luck for your results, and always my wishes is with you. Okay, so again we will meet again with some new subject, okay, some new concept, okay, in our this global channel. Okay, thank you guys.
Hi guys. How are you? First of all, tell me, is audio is proper? So I hope your GATE exam has been gone well. So let's see the machine questions. And all the machine question, total 7 question has been asked from machine. And all the questions are very easy, formula based question. There is no any question which was tricky. Okay. So let's see. This question has been asked from induction motor. A 3-phase 415 volt 4-pole 50 hertz induction motor draws 5 times the rated current at rated voltage at starting. That means 5 times the rated current at rated voltage at starting. That means at starting, without any starting method, the starting current we are getting 5 times the rated. That means this current should be short circuit current, because at starting slip is 1. So ISC is equal to 5 times IFL. This is our equation number 1. Or we can say simply ISC is equal to 5 times IFL, direct online starting. Okay. It is required to bring down the starting current from 2 times of rated current using a 3-phase auto transformer. That means now we are going to apply a starting method, and we are using a 3-phase auto transformer to reduce the starting current. So after using the auto transformer, our starting current should be 2 times of full load current. This is our second equation. So if the magnetizing impedance of the in the induction motor and no load transformation ratio of the transformer is given by. So as we know, in auto transformer, I starting is equal to x square. That means starting current at supply side is equal to x square I starting. Okay. So from this equation we have starting current is 2 times of full load. So 2 into IFL x square and IST x square IST. तो स्टार्टिंग में कितना करंट गया था, कितना है 5 टाइम्स. दिस इज ISC. So 5 times of IFL. Okay. So this and this will be cancelled out. X square is equal to 2 by 5 and x will be root over 2 by 5. If we solve this, 1 minute. 1 minute. If we solve this, we get 0.632. So 0.632 is the transformation ratio of auto transformer. ओके तो ये हो जाएगा ट्रांसफॉर्मेशन रेशियो. ठीक है, चलिए नेक्स्ट क्वेश्चन देखते हैं. 1 minute, इज देयर एनी प्रॉब्लम? हाँ, नेक्स्ट क्वेश्चन है a 280 volt separately excited DC motor with armature resistance of 1 ohm, consistent field excitation drives a load. The load torque is proportional to speed. The motor draws a current of 30 ampere when running at a speed of 1000 rpm, neglecting friction and windage losses. So RA we have given 1 ohm, terminal voltage is 280 volt, and in first case the motor is draw. Let's suppose this is case number 1. IA1 is 30 ampere, running at a speed of N1 is 1000 rpm, neglecting friction and windage losses. The speed in rpm at which the motor will run if additional resistance of 10 m. So we are adding R external of 10 ohm is connected in series with the armature. So we have to find the speed, and one more relation we have been given, that torque is proportional to speed. Okay, so we have been asked the speed N2 when we add external resistance of 10 ohm. Okay, so whenever speed has been asked, always try to find back EMF. So back EMF EB1 is equal to VT minus IA1 RA. VT is 280, IA is 30, RA is 1. This is 250 volt. This is EB1 at, and this back EMF we are getting when speed is 1000 RPM. Okay, now we have to find the another back EMF. We have to find the current. So we have been given a torque relation, that torque is proportional to speed. So from this we can say that T2 by T1 is equal to N2 by N1. T2 by T1 will be T2 by T1 K phi omega R2 divided by K phi omega R1, that is, sorry, omega nahi, IA1. IA2 divided by K phi IA1, that is N2 by N1. So we have been given a separately excited motor. So this K is a constant and flux is also constant because we have a separately excited motor. So we have a relation between IA2 by IA1 will be 30, N2, N1 is 1000. first equation. Okay. Next, we have been asked the speed. So we know that EB or EA, back EMF is equal to K phi omega R. Okay, K phi omega R. So from here, K phi back EMF is proportional to phi is constant, K is constant, and this omega R is speed in radian per second. This is 2 pi n by 60. So EB is proportional to speed. So from here, EB2 by EB1, N2 by N1. What is the value of EB2? Terminal voltage minus IA2. RA is 1, R external is 11. Sorry, R external is 10 ohm. So this will be 11. So EB1. What is the value of back EMF in first case? This is 250 RPM. 250 volt, and it is equal to N2 by N1. So N2 we have to find, and N1 is 1000. And we also know the value of VT, that is 280. Okay, now we have to solve this equation. So 280 minus, what is the value of IA2? IA2 is equal to 30 into N2 divided by 1000. That means 3 by 100. So 30 divided by 1000 into 11 into N2. Okay, divide by 250, N2 by 1000, N2 by 1000. Okay, now solve this. If we solve this, 280 into 1000 minus 30 into 11, 330, N2, and this 1000 and this 1000, 250, this is N2 by 1000. So from here, this 1000 and this 1000 will be cancelled out. So what is the value of N2? What is the value of N2? What is the value of N2? Here, this 250 is also come here. So if we take this 280 into 1000 and take it from this side, so 330 plus 250 N2. So from here N2 will be 280 into 1000 divided by 330 plus 250. Find it. 280 into 1000 divided by 330 plus 250. You will get 482.75 RPM. Okay, so if we add 10 ohm resistance in series with the armature winding, then speed will definitely reduce, because in flux or field control method we get the speed more than rated, but in armature resistance control method to reduce speed control we get speed from below from rated. So definitely we will get a speed less than 1000 RPM. That is 482.75. Is that clear? That is the speed. when we add 10 ohm resistance in series with armature. Okay, let's see the next question. The type of single phase induction motor expected to have a maximum power factor during steady state running condition. We have been given some type of single phase induction motor, and we have to select which motor is suitable at which we get a good power factor or we get a maximum power factor under a running condition. So we add capacitor to make the single phase induction motor self-starting, because single phase induction motor is not a self-starting. So for that we have to require some capacitor. If we use capacitor to start as well as we have the capacitor at running condition, then we are using capacitor at starting to start the motor, to make the motor self-starting, and at running condition if we are using the capacitor at running condition, so at that time we get a good power factor at running condition, because at running condition we have the capacitor, so this capacitor will deliver lagging reactive power. This capacitor will deliver lagging reactive power, lagging Q. So motor does not take to lagging reactive power from the supply. If motor do not take the lagging reactive power from the supply, if we have already the capacitor at running condition, then automatically the power factor of the induction motor will be very good at running condition. So option number C will be the right answer of this question. Capacitor start, capacitor run motor is the type of induction machine in which we get a good power factor at a running condition. So it's very simple question. Next question. A star connected 3-phase synchronous motor, 400 volt 50 kVA 50 Hertz, has a synchronous reactance of 1 ohm per phase with negligible armature resistance. The shaft load on the motor is 10 kilowatt while the power factor is 0.8 leading. The loss is 2 kilowatt. The loss is 2 kilowatt. The magnitude of per phase excitation, EMF of the motor in volt. So first we have given the supply voltage, terminal voltage, that is 400 volt, and always the voltage that has been given, that voltage is always line voltage. So line voltage we always have been given, that is the line voltage. Okay, next the motor synchronous reactance XS is given as 1 ohm per phase. Per phase synchronous reactance is given as RA is negligible, armature resistance is negligible, 0. The shaft load on the motor is 10 kilowatt. So P out or P shaft, that is given 10 kilowatt. That is given 10 kilowatt. The power factor is cos phi. The power factor is 0.8 leading. Losses we also have been given. Losses we have been given 2 kilowatt. And we have to find the field excitation, magnitude of field excitation per phase. This has been asked. This has been asked. Yes dear, क्वेश्चन जेई लेवल के ही हैं, एक आधा एक क्वेश्चन जेई लेवल का ही है, ठीक है. सो वी वांट द वैल्यू ऑफ आर्मेचर करंट. ओके, so the equivalent circuit of synchronous motor as well as synchronous generator is very easy. Just a reactance, here is the excitation, Here we have a terminal voltage, that is Vt at an angle 0 degree, and here we have field excitation. Here angle should be negative, that so that power will transfer from this side to this side. And here we have J1 ohm per phase, and we have to find the armature current. First we need the armature current. What is the current flowing in the armature? So how we can find the, let's see. We have been given output power as well as losses. So we know that if we add output power and losses, we get the input power. So what is the value of input power? P input power is, P out is 10 kilowatt, and this is 2 kilowatt, this is 12 kilowatt. So 10 plus 2, that is 12 kilowatt. That is the P in. That is the P in. Okay. So we know that P in is root 3 VL IL cos phi. So IL is the armature current, and by default we take the three-phase connection is in star. So in star, line current and phase current are same. So this current is the armature current, IA. So what is IA? What is the value of IA? IA will be 12 into 10 to power 3 root 3. What is the value of VL? 400 into IL cos phi. Power factor is 0.8. Calculate this. This is 21.65 ampere. 21.65 ampere. So now we have to apply the magnitude form of EF. EF. So we know that EF square is Vt cos phi minus IA RA whole square plus Vt sin phi plus IA XS whole square. So what is the value of EF? EF is root over Vt. So this is the per phase equation. This is the per phase equation. So Vt is Vt by root 2. So we have 400, Vt by root 3, 400 by root 3. Per phase volt, power factor is 0.8, minus IA is 21.65, and RA is neglected. And Vt is 400 by root 3 into 0.6 plus IA will be 21.65, and XS is, what is the value of XS? 1. Calculate this. Calculate this. $244.54 volt. That is the answer. 244.54 volt. That is the answer. Okay. Now let's see the next question. The frequencies of stator and rotor flowing in 3-phase 8-pole induction motor are 40 Hz and 1 Hz respectively. The motor speed in RPM is we have to find the speed of the motor, and we have been given the frequency of stator and rotor currents. So stator current, that means frequency of stator. Frequency of stator is 40 and frequency of rotor is 1. So we know that rotor frequency is always slip frequency, that is SF. So from here we get the value of S, that is S into 40. So what is the value of S? 1 by 40. Okay. We know that rotor speed is less than synchronous speed, and it is less by slip speed. So NR is synchronous speed minus slip speed, that is SNS. So NS, what is the value of NS? NS is 120 F, F is 50 upon P, 15, no, it is 40 has been given, divide by 120 F upon P, and number of poles are 8. So this will be 600 RPM. So this is 600 minus slip will be 1 by 40 into 600. This and this cancel out, this is 15. So we have 585 RPM, that is the speed of rotor. Definitely, this question is also very easy question. 2 questions are very easy. So this year machine questions, all machine questions are very easy. Next, this question is little bit calculative. This question is little bit calculative. 2 generating units rated for 250 megawatt and 400 megawatt have governor speed regulation 6% and 6.4% respectively from no load to full load. Both the generating units are operated in parallel to share a load of 500 megawatt. Assuming free governor action, the shared in megawatt by 250 megawatt generating unit. That means when both generator have capacity to share, generator 1 can share 250 megawatt and generator 2 can share 400 megawatt, but that 2 generator are operating in parallel and their speed regulations are like this, 6% and 6.4%, and they are sharing 500 megawatt. So we have to find what is the load shared by 250 megawatt generator or generating unit. So first generating unit can share 250 megawatt. So this is the P1 or PFL1. That means full load. When they are working at full load, then they can share 250 megawatt, PFL1. Second generating unit can share 400 megawatt, that is PFL2. That is PFL2. Okay. Now we don't know the frequency at no load condition. So we know that both the generator at no load, the frequency of both the generator at no load will be same. At no load, there is no any reduction in the frequency. So we can assume any frequency to calculate this. So assume no load. Assume no load frequency is 50 hertz. You can assume any frequency. So from this FNL1 at no load, frequency of generating unit 1, no load frequency of generating unit 2, that is 50 hertz. According to that, we get the operating frequency. Okay. Next is the speed regulation. So generating unit 1 have speed regulation equal to FNL1 minus FL1 divided by FL1 multiplied by 100 equal to 6%. What is the speed regulation? Frequency, no load frequency of generating unit 1 minus full load frequency of generating unit 2 divided by full load frequency of generating unit 1 and 1. So all these frequencies are belonging to generating unit 1. Okay, this is 6%. So can we find here the full load frequency? This will be 100. Okay. So FNL1 is 50. This is 50 minus FFL1 equal to multiplied by 100 equal to 6 FFL1. Okay. So from here FFL1 will be, this 100 will be here. So FFL1 is 100 plus 6 into 100 into 50. So what is the value of FFL1 is 100 into 50 divided by 106. I think there will be some tell me 6%. 50 into 100 divided by 106. We get 47.16. 47.16 from 169, so 17 hertz. Speed regulation of generating unit 2 is FNL 2 minus FFL 2 divided by FFL 2 multiplied by 100, and this will be 6.4%. So when you calculate these, you will get, I have already the data. When you calculate this, so what is the value of FFL2? The value of FFL2 is 46.992 hertz. Okay, so now we have both FFL, full load frequency of generating unit 1, full load frequency of generating unit 2 according to their speed regulation. Now we can find the droop characteristics. What is droop characteristics? P1 is equal to, D1 is equal to, 1 minute. We know that P is equal to P1 plus P2 equal to 500. Okay, that means now P1 is, what is the value of P1? P1 is D1 F NL1 minus F operating plus D2 F NL2 minus F operating. That is equal to 500. So first of all, we have to find the droop characteristics of first generating unit and droop characteristics of second generating unit. Droop we have to calculate. So how we can calculate a droop? So we have P1 is equal to D1 F NL1 minus F operating. Okay, so D1 will be P1 upon F NL1 minus F operating. Minus F operating. So we cannot find D1. We cannot directly find D1 because we do not know F operating. We do not know what is the value of F operating. We do not know. So how we can find D1 and D2? We can find D1 is P1 upon FNL1 minus FFL1 250 upon 50 minus 47.17. 47.17. When you calculate this, we will get 88.339 megawatt per hertz. D2 will be P2 FNL2 minus FFL2 450 minus 46.992. 132.97 megawatt per hertz. Now we put the value of D1 and D2 here. So put the value of D1 here and D2 here. So we can get the operating frequency. So D1 is 88.339 50 minus F operating plus 132.97 50 minus F operating equal to 500 equal to 500. So 88.339 into 50 minus 88.339 into F operating plus 132.97 into 50 minus 132.97 into F operating equal to 500. Now we have to find the value of F operating here. So I'm directly write the value of F operating. I'm directly write the value of F operating. Just one more step. This and this. Negative term, that term will come here. This value will come here. So F operating is and we can also take 50 from here, 50 common from here, 50 into 88.339 plus 132.97. These both value will come here. This 500 minus 500 will come here. Now here 88.339 plus 132.97. Calculate this. .74 hertz. Now we have to calculate what is the power shared by generating unit 1 according to speed regulation. So P1 is droop characteristics D1 FNL1 minus F operating. So D1 is 88.339. minus 47.74. $88.339 50 minus 47.74, that is 199.64 megawatt. That is the answer. Okay. So if we want to calculate what is the value of second generating unit, so simply D2 F NL1 NL2 minus F operating. Simply, what is the value of D2? This has not been asked. What is the value of D2? 132.97. 132.97. This will be 50 minus 47.74. So you will get 132.97. 300.51 megawatt. Okay, this is 300.51, this is 199.64, and both will share 500 megawatt load. Okay, next question. I think this is the last question. This is the last question. In this question, a 4-pole induction motor, we have been given an inertia, drives a constant load, torque is constant, and the value of torque is 2 Newton meter. The speed of the motor is increased linearly from 1000 rpm to 1500 rpm in 4 seconds. Neglect the losses of the motor. Energy in joule consumed by the motor during the speed change. Okay. So we have been given the curve between speed and time, and we have to calculate the energy. Okay. So we have the relation between, that is, P is equal to T into omega. Okay. So if you simply multiply here by T and here T, what is this? Sir, this is the energy. What is this? This is theta. So omega into T curve, we have been given a speed in RPM versus time curve. If we multiply here 2 pi by 60, we get the speed in radian. If we take RPM into 2 pi by 60, then the speed will be in radian per second, that is mean omega. So this is 2 pi by 60. Okay. Now simply just calculate the area between these curves. We get the theta value. Okay. And torque has been given to us. So energy will be torque is 2, and what is the area? This 1000 into 2 pi by 60. 1000 into 2 pi by 60 into 4 plus 1 by 2, 500 into 2 pi by 60. Just calculate this. We get 1047.19 joule. Okay. ठीक है. Simply we can find theta, that is omega into T, 1000 into 2 pi by 60 into 4, that is 4 into 4 area of this, and 1 by 2 1500 minus 1000, 500 into 4, 2 pi by 60. Okay. So we get 1047.19. So these are the all 7 solution of machine question. Okay. So thank you.
Am I audible, guys? Am I audible properly? Am I audible? I think audio is not coming. Audible? Okay, so here y of t is equal to, here y of t is equal to what? K into y of t, which is equal to what? K into x of t. Let us mark this is the scaled output. And again you can compare, guys. Again you can compare, this is 3 and this is 4, guys. So 3 is equal to 4, so it satisfies the principle of homogeneity also. So put together it satisfies the principle of linearity and the principle of homogeneity. That's why it is a linear system. This is what? Linear system. So you can cancel option A, option C, eliminate. Now we have to check the system causality. So for that, find the output at t equal to 0. You want to find the output at t equal to 0. He wants to find output at t equal to 0. So y of 0, simply y of 0, which is equal to x of e to the power 0. So which is what? Which is equal to x of 1. So we wants to find output at t equal to 0, and for that you require input at t equal to 1. So you require present input for the, you require future input for the present output. Okay, see here you want to find output at t equal to 0, and for that you require input at t equal to 1, future input required. So here present output depends on the future input. Okay, so that's why it is a non-causal system. So here non-causal, option D also eliminated. That's why here option B is the correct answer of this question. Linear and non-causal. Clear? Linear and non-causal. Okay, so this is the first question from the signature system, which is very much easy, guys. Now here let us see this question. Let us see this question. So here it is given, let a causal LTI system be governed by following differential equation. One differential equation is given whose x of t and y of t are the input and output respectively. It's a impulse response. Okay, so here basically one differential equation is given, x of t, y of t are input and output respectively. You have to find the impulse response. So for impulse response, if you want to find impulse response, input should be impulse. So you can use here Laplace transform. By using Laplace transform you can get the answer very much easily. So see here Laplace transform, if we apply Laplace, so y of s equal to, here initial conditions are not given. Okay, so we will take initial conditions are 0, 1 by 4 here dy by dt. So it is nothing but s into y of s, its Laplace, and here 2 into x of s. Now see here for impulse response input should be impulse. That's why here it's Laplace x of s equal to 1. So simply put x of s equal to 1. So y of s plus, y of s is common, 1 plus s by 4, which is equal to 2 into 1. Okay, so y of s is equal to 4 upon, here it is 8, 4 multiplied by 2, which is equal to 8. So 8 divided by s plus 4, simple. 4 multiplied by 2, this is not 2.1, it is 2 into 1. So it is 8 divided by s plus 4, and you have to take inverse Laplace after that. So y of t is equal to simply 8 into e to the power minus 4t into u of t. So here correct answer is 8 into e power minus 40 into u of t. Here option A should be correct answer of this question. Got it? Simple Laplace transform. By using Laplace transform you can solve this question. Now here one more question like this, guys. Okay, this is question. Here one LTI system is given and its impulse response also given, h of t, this is its impulse response, and input is given. So for this input, for the LTI system whose impulse response is this one, you have to find the output y of t, output y of t. Correct, output y of t you have to find. So see here, now just identify this one, guys, just identify this one. Okay, already I covered in my class also. This is nothing but simple band pass filter. Okay. Now see, this is sine 80 by pi t standard sine 80 by pi t, sine 80 upon pi t, whose Fourier transform is given by let us consider simple sine 80 upon pi t, whose Fourier transform is nothing but rectangle pulse, frequency is omega. Here rectangle pulse from minus a to plus a with amplitude 1. Okay, and if you multiply this with cos, then this spectrum, this is known as spectrum, like let us consider x of omega if this is x of t, if this is x of t. Okay, and if you multiply this x of t with cos function, then this spectrum will shift right hand side by certain frequency, left hand side by certain frequency, amplitude is decreased by factor of 2, guys. So in our question, this is sine 10 pi t by pi t, or we can say 2 sine 10 pi t upon pi t. So here if you compare this, then you will get a is equal to here, a equal to 10 pi. So for this, its a Fourier transform is nothing but rectangle pulse from minus 10 pi to 10 pi with amplitude. Here see, amplitude is 2, guys. Here amplitude is 1, that's why 1 here. Here amplitude is 2, that's why 2, correct? So this is 10 pi. Now if you multiply this signal sine 10 pi t with cos here 40 t, see it is given cos 40 pi t, then here this spectrum will shift right side and left side by 40 pi. Frequency is what? 40 pi, this much frequency. This will shift, this spectrum will shift right side as well as left side by this 40 pi, and amplitude is decreased by a factor of 2. This is the property. Okay, modulation property also we can say. So basically this is a low pass filter, and if you multiply with cos, then it will be a band pass filter. It will be like this. Simply right side, shift this spectrum right side by 40 pi. Simply you have to add 40 pi. So it will be from 30 pi to, if you add 30 pi to 50 pi, simple. Okay, and here also left side also simple, minus you have to same thing, subtract 40 pi from this, that is this one, and amplitude is decreased by factor of 2. So amplitude is 2, that's why amplitude is here 1. So this is your Fourier transform of the system impulse response. Okay, this one, this is the impulse response. Okay, now LTI system. Okay, LTI system, this is input is x of t, and here output is y of t. Okay, now here input is sinusoidal frequency components sine 10 pi t. So here frequency, see here frequency is 10 pi, here frequency is 15 pi, here frequency is 42 pi. Okay, here frequency is 45 pi, correct? These are the different frequency components present in the input. Now here this is the band pass filter which passes the frequency which lies between the 30 pi and 50 pi only, because other than this range magnitude is 0, correct? Here spectrum magnitude is 0 other than this range. So this band pass filter will pass only the frequencies which lies between 30 pi and 50 pi. So here see 10 pi, so this band pass filter will reject 10 pi, correct? 10 pi here, this is 10 pi, so you can see at 10 pi magnitude is 0. Okay, so that's why it will reject this 10 pi frequency component. This one 15 pi also it will reject 15 pi, this second function also it will reject. Then 40 pi, yes, so of course this will pass. Okay, 45 pi also, this also will pass, guys. Okay, and see here important part is here magnitude is 1, so you have to multiply magnitude 1 at input frequency, guys. So here input frequencies are, we can say 42 pi and here 45 pi. Correct? Correct? So here, so what will be the output? So we can say output is y of t is equal to simply 7 sine 42 pi t plus 4 cos 45 pi t. Is this clear? I hope all the students are getting. So this is the final answer. You can choose the correct answer from the given options. Okay. So this is also very much important question, and the rank deciding question is this one, guys. Okay, this is very much interesting question from the discrete time Fourier series. Okay, so one signal x of n whose dtfs is given. This is the discrete time Fourier series representation of one discrete time signal x of n. This is given. Okay, and this is the standard formula also, we can say. Okay, here they are mentioning that fundamental time period of x of n is n equal to 3. A minus 3, one component A minus 3 is nothing but 2, A4 equal to 1. And here you have to choose what is the correct answer for the x of n. What is the correct option for the x of n? Okay, this is the simple question. X of n is given. They are saying that fundamental time period is 3. A minus 3, one component coefficient is given. One more coefficient is given. Okay. Now, if you remember discrete time Fourier series, then in DTFS, if the signal is x of n and it's a Fourier series DTFS, discrete time Fourier series coefficient is Ck, correct? Coefficient is Ck. See here. So this is what, this is of course Fourier series defined for the periodic signal and it is for the discrete time signal. So in time domain the signal is periodic and discrete, then in frequency domain periodic become discrete, discrete become periodic. So here also this Fourier series coefficient Ck also discrete and periodic, guys. So x of n also periodic, Ck also periodic, and both have the same fundamental time period. Okay, both have the same fundamental time. This is the periodic with the fundamental time period n, and this is also periodic with the fundamental time period capital N, guys. Correct? So here x of n also periodic. We can say x of n is equal to x of n plus or minus n, because this is periodic, of course. Okay, and here Ck also you can say Ck is equal to Ck plus or minus n. Okay, you can say like this. Okay, got it. Now see here A minus 3 is given. Here notation is Ck. In actual it is notation is Ck. For CTFS notation is Cn. For DTFS notation is Ck. But in the question notation they have given A int Ak. Okay, so here I am writing Ak. Now observe the coefficient. Observe this coefficient A minus 3 which is equal to 2. Okay, so can we write like this? According to this, A k plus n, A k plus n, which is nothing but what? Here k equal to minus 3. So A minus 3 and n equal to 3. So this is nothing but your A0. This is nothing but your A0. So we can say A0 is nothing but 2. Correct? Okay. Similarly A4 which is equal to what? A 4. See, this is k plus or minus n. So you can write minus 3 also, or you can say plus 3 also. Okay, so you can write A1 also and A7 also. So here I am writing A1, which is nothing but, it is according to this, okay, periodicity, it is nothing but here it is 1, guys. So we got A1 and A0 first of all. First of all, we got A0 is equal to 2 and A1 is equal to 1. Correct? A0 equal to 2, A1 equal to 1. So here this indicate, what indicate? K equal to 0. This indicates k equal to 1. Now here standard format x of n equal to summation k is equal to 0. Here n equal to n equal to what? N equal to, or we can write n minus 1. Ck, instead of Ck I am writing Ak, because it is mentioned in the question, k into n. Now x of n will be, see, now put k equal to 0. If you put k equal to 0, e power 0 1, so it will be a0, and if you put k equal to 1, then it will be a1 into e to the power j 2 pi by 3, k equal to 1, correct, into n. Now put the value of a0. So here a0 is 2 and here a1 is 1 into e to the power j 2 pi by 3 n. Now there are different ways. You can make adjustment here also and you can get the correct option. These 4 options are given here, correct? So you can make adjustment here, and one more method is what? By elimination, option elimination. So see, this is x of n. So if you put x of 0 here, x of 0, that is n equal to 0, then here 2 plus 1 guys, 2 plus 1, which is nothing but here it is 3, correct? So x of 0 at origin, signal value is 3, okay? Now here, in which option at n equal to 0, put n equal to 0, so here you will get 4, so option A is eliminated. Now here also option B. Now you can choose the correct answer from C and D. So what is the difference? What is the difference? Here it is 2 pi by 6, here it is 2 pi by 3, or you can say pi by 3 and 2 pi by 3. So now you can put one more value like x of 1, guys, correct? X of 1 here. So here x of 1, that is 2 plus e to the power j 2 pi by 3, which is nothing but cos 2 pi by 3 plus j sin 2 pi by 3. So which is equal to 2 plus, and this is cos 2 pi by 3, that is minus 1 by 2, and sin 2 pi by 3, that is j 0.√3 by 2, that is 0.867 or 866. This is the answer, which is equal to 2 minus 0.5, 1.5 my plus j 0.866. Okay, got it? So this is x of 1. Now from the option C, if you put option C n equal to 1, x of 1 n equal to 1, if you put n equal to 1, that is what? Here n equal to 1, so 1 plus 2 into e to the power j pi by 3. So it is nothing but cos pi by 3 plus j sin pi by 3. So 1 plus 2 cos pi by 3. Cos pi by 3, that is 1 by 2. Correct? Sorry. 1 plus 2 cos pi by 3 2 into, okay, something is missing here. It is cos pi by 6 and also missing, I think, in option. Just wait for a minute. Something is missing in the question. Yes, here it is cos 2 pi by 6 into n. Here also cos 2 pi by 6 into n. This is missing part. Here also cos 2 pi by 6 into n, and here also cos 2 pi by 6 into n, correct? So multiply with here e power j cos pi by 3 also, guys. So cos pi by 3 1 by 2, 1 by 2, 1 by 2 cancel out, this one and this cancel out, so here 2 gone, here 2 gone, guys, correct? So here cos pi by 3, that is 1 by 2 plus j 0.866. okay, so finally you will get 1.5 plus j 0.866. Now option C is correct, so need not require to check option D also. Here option C is the correct. So this is the challenging question, we can say, or rank deciding question from the signals and system. Total they asked total 4 questions, okay, from the signals and system. One more question is there, but you can consider it in control system also, guys. Okay, like sinusoidal steady state response. So these are the 4 questions from the signal sense system, and they asked from the DTFS also. Okay, so this is from the signal sense system.
हेलो हेलो आवाज क्लियर है? इस साउंड इज क्लियर? यस यस गुड इवनिंग फ्रेंड्स, welcome to Gate Academy Global channel. So this is Satish Kumar Dirshetty, Faculty of Measurements and Instrumentation. How are you all? How did you write this GATE EEE paper? I think many of the students of EE are happy because the paper was so easy as per my analysis, except analog paper, analog question, remaining all subjects with respect to electrical, it was so easy paper. With respect to measurements, how did you feel? Yes, please all of you just watch this session. Here are the questions which came from the measurement subject. From measurements we got 2 questions. One question came from the fundamental bridges and the other question came from the star delta model. Okay, let us see this question. Question number 23. A balanced Wheatstone bridge ABCD has the following arm resistances: RAQ, this RAB, sorry, 1 kilo ohm plus or minus 2.1%, RBC 100 ohms plus or minus 0.5%, RCD is an unknown resistance, RDA is 300 ohms plus or minus 0.4%. The value of RCD and its accuracy is dash. That was a question. So how to answer this question? Can anybody type the answer here? So if you see the question, so this is our Wheatstone bridge. So this is a A, this is a B. Yeah, you can take this as B and you can take this as C and you can take this as D. RAB 1000 ohms plus or minus 2.1%. RBC 100 ohms plus or minus 0.5%. RCD is an unknown resistance. RDA 300 plus or minus 0.4%. So 300 plus or minus 0.4%. So this is our Wheatstone bridge circuit. Very simple question. He is asking to measure this RCD value. Okay. So can anybody type the answer please? What was your answer for this Wheatstone bridge question? Very simple. It balance, what we can write? It balance
we can write as product of RAB, RCD, RBC and RAD, these all are equal. So from this I can write RCD is equal to RBC into RAD by RAB. Yes or not, my dear? Yes. So now if we check this RBC, so this is 100 and RAD is 300, RAB is 1000. So this is 30, but if you see the percentage error in RCD, as it is a product and quotient, so we can take it as the summation of the percentage errors. So all the percentage errors, if you take 2.1 plus 0.5 plus 0.4, so it will be 0.5 plus 0.4, 0.9 plus 2.1, so that will be plus or minus 3%. So if you check the 3% of 30, so it will become 0.9 ohms. So we can write the value of RCD as how much, my dear? So 30 ohms. How many of you got the right answer? So this is 30 ohms plus or minus 0.9. 30 plus or minus 0.9%. No, it's not percent usual, 0.9. The percentage is 3%. In percentage it is 3%, but in absolute value it is 0.9. So the right answer will go for 30 plus or minus 0.9 ohms. 30 plus or minus 0.9 ohms, my dear. The right answer is 30 plus or minus 0.9. Now let us go for the one more interesting question. I think all of you got this answer, option C. Ujjwal, yes. The right answer is 0.9 ohms, not percentage. 3% is the percentage, 0.9 is the thing. Now let us go for this one. This question, how many of you got it? This question. Yes, tell me. Is it streaming well? Yeah. Yeah. How to answer this question? So if you see this question is a combination of measurements and networks. So if you see this circuit, he has given internally one star connection and outward one delta connection, and he has given the sequence as RYB sequence. So 3-phase loads, 2 balanced 3-phase loads as shown in the figure are connected to a 100√3 volts 3-phase 50 Hz main supply given. The impedances are given clearly. The Z1 is 18 plus J 24 ohms. Z2 is 6 plus J 8 ohms. The ammeter reading in amperes is asking. So how to do it? So if you check this now, so this part if I am taking here, so how to solve this circuit first of all? So first of all, as it is a combination of star and delta, yes, any answers please? So now if you check this This is a combination of star and delta. So this is star connection. So first you have to convert the star into delta model. So how to convert? So if I am taking this as delta like this, yes, this is a delta model. So let me take this as ZX, this as ZY, this as ZZ. So what happens to the ZX now? If you check the ZX, ZX will be what? It will be the Z2 into Z2 plus Z2 into Z2 plus Z2 into Z2 the whole divided by Z2. So that becomes it as what? Z2 whole square, 3Z2. It will become ZX as 3Z2, the same like ZY, 3Z2, and ZZ also. So this ZZ also 3Z2. ZX, ZY, ZZ, 3Z2. Okay. So now what happens? This ZX and Z1 will be in parallel. So this circuit will become like this. So if you check, this circuit is going to become finally like this. This is the Z equivalent we are going to take. So this is going to be Z equivalent, my dear. So this is the Z equivalent, this is the Z equivalent, this is the Z equivalent, and now from this, so this is our ammeter connection, this is a Y, and this is our B sequence. So this is our R, this is our Y, and this is our B, and this voltage he has given as 100 root 3, and this is the current entering. So first of all, if you see the Z equivalent, so how to calculate the Z equivalent, my dear? Okay, if you check the Z equivalent, what is the Z equivalent? So Z equivalent is nothing but the parallel combination of Z1 and ZX. Am I right or not? So if you take the Z equivalent, it is a combination of Z1 parallel with ZX. So that will be Z1 parallel with 3Z2. Am I right or not? 3Z2. So if I am taking this combination, so Z1 into 3Z2 by Z1 plus 3Z2. So what is Z1? 18 plus J24. So if I am taking that Z equivalent expression, so if I am taking that Z equivalent expression, my dear, so what is going to be? Z equivalent will be equal to Z1. What is Z1? That is 18 plus J24. So this is 18 plus J24 into 3 times of Z2. Z2 is 6 plus J8. So this is 6 plus J8 whole divided by 18 plus J24 plus 3 times of 6 plus J8. So if I multiply this 18 plus J24, so this is 18 plus J24 the whole divided by 18 plus J24, 18 plus J24. So Z1 Z2 by Z1 plus Z2, that is nothing but a parallel combination we are getting. That means I can write it as 18 plus J24 whole divided by 2. So that will become 9 plus J12. Okay. So we got the Z equivalent, my dear. We got what? The Z equivalent we got as 9 plus J12. Once you get the 9 plus, yes. Any answers please here? Yes, 9 plus J12 we got the Z equivalent. So that if we substitute here, so this is how much? 9 plus J12. This is also 9 plus J12. This is also 9 plus J12. So if you see this phase current now, so what is IPH? sorry, that is the current entering, sorry. So this is the current entering here, current entering here. So if you see the IPH, I can write it as VPH by ZPH. For delta model, we know VPH is equal to V. See, for delta model, VPH is equal to VL. Yes or not? VPH is equal to VL is equal to VPH. VL is equal to VPH. IL is equal to root 3 IPH. Got it? So I need the IPH. First of all, I need the IPH. So what is the IPH here? If you check the IPH, that is VPH by ZPH. VPH is equal to VL. ZPH means this is the magnitude of the ZPH if you take. So VL is given as how much, my dear? It is given as 100 root 3. 100 root 3. And if you take the magnitude of ZPH, 9 plus J12, so this is a 9 square plus 12 square. So if you check now, this will be 100 root 3. This is 9 square 81 plus 144. That means it is coming as 225. Under root of 225, that is 15. So this is IPH, but many students will commit the mistake here. Didn't ask you the question of IPH. He is asking the question passing through this ammeter. Passing through the ammeter means that is a line current, my dear. So this is the IPH which is passing through the phase, and this is a line current. Both are not same. So what I can write here, we got IPH. So from this we can go for the IL. So IL is equal to root 3 into IPH. So I can take this as root 3 here. IPH is 100 root 3 by 15. So now the line current we are going to get as 100 into 3 by 15. So the right answer will be coming as 20 amperes. So how many of you got this answer? So right answer is 20 amperes. Very good question. Fundamentally concepts of measurements and networks. Measurements and networks. So the right answer for this question is 20 amperes. Right answer for this question is 20 amperes. Only 2 questions came from the measurements. 1 question came from the bridges, and 1 question came for the this one. 3 star, star to model, delta to star. So based on this, we can expect tomorrow is the IN paper, instrumentation paper, but I expect in instrumentation paper more number of questions from the measurement subject. I can expect more number of questions in the measurement subject. Okay, my dear? Yeah. So from this, I am stopping this lecture. So I wish you a best of luck. Those who are already written, please relax well and prepare well for the EC people and IN people. Especially IN people, tomorrow is exam. So I expect more number of questions from the measurements for tomorrow's exam. I wish you all the best for IN people, especially for sensors and industrial instrumentation, optical instrumentation, process control instrumentation and measurements. Please have a nice preparation. Thank you very much. Thanks for watching the Global Gate Academy. Thank you.